A confirmation about the audio, please. If the audio is clear and available, please confirm the same. Thank you. I hope everybody is doing good. Yes, I'm fine. Thank you. Thanks for the kind wishes, guys. Doing good. So, hello, a very warm good evening to all of you, and welcome to Baiju's Exam Prep IAS. Welcome to another session of geography, where in the previous session we have been discussing about the portion of Indian monsoon. Now, we had discussed and we had been discussing about the various factors which end up influencing the Indian monsoon. Now, amongst the various factors that we had discussed, we had basically discussed the portions with regards to the aspect of the heating of land and water, the differential rate of heating of land and water, the shift of the ITCZ that we have. Also, we have discussed about the aspect of the mascarene high pressure belt which develops. We have discussed the role played by the subtropical westerly jet stream. We have also held a discussion about how is it that a tropical easterly jet can end up strengthening the monsoon. Now, after these factors, we come to the factors of El Nino, La Nina, and also the influence of Indian Ocean dipole when it comes to the Indian monsoon. And after that, we will be moving ahead with the portion of what do we understand by retreating monsoon, what do we understand by the northeast monsoons, and also what is understood by western disturbance in general. So those are the areas that we shall be focusing upon. So we start first of all with the impact of El Nino and La Nina created on the monsoonal system. Okay. So when we say impact of El Nino and La Nina, now, these are the different circulations which are initiated in the Pacific Ocean, something that we have already studied. Now, we have taken a detailed look that when we say El Nino, now in the case of El Nino, you have warmer waters which end up developing in the region of Eastern Pacific. And in the case of La Nina, a significant warmer water pool gets developed in the region of the Western Pacific. Now that induces an atmospheric circulation, and that atmospheric circulation, in a way, influences the mascarene high pressure. So once the mascarene high pressure is influenced, that is where you have the influence which is impacted, which is observed, which is felt, even in the case of the Indian monsoonal system. So when we talk about El Nino and La Nina here, basically circulations induced influences the mascarene high pressure in southern Indian Ocean. Okay, and the relation after that is quite simple. Any impact which will strengthen the mascarene high pressure, which will make the high pressure much more stronger, any of those. So basically, any of those factors which will strengthen the mascarene high pressure, that factor will bring about a stronger Indian monsoon, and the vice versa will also play out. So any influence which strengthens the mascarene high pressure will strengthen the Indian monsoon and vice versa will also play out. So, heating of oceanic waters in the Pacific, that is what creates heating and cooling of oceanic waters in the Pacific. That is what ends up creating El Nino and La Nina circulations and impacts of El Nino and La Nina. They are observed, they are felt by that heating and cooling of the oceanic water. So, heating of oceanic waters in the Pacific, which ends up creating ENSO conditions in the Pacific Ocean, also end up having a distinct influence over the Indian monsoon. Conditions of El Nino decreases the overall rains received by India during the monsoon months and overall as well, whereas La Nina creates a condition of a higher than average rainfall. So El Nino season and El Nino months and years, they will always end up creating a slightly higher than average amount of rainfall. And also in the case of La Nina, or rather to pardon me, El Nino will create a condition of deficient rainfall and La Nina will create a condition of excessive amount of rainfall received. So here first of all understand what is created during the condition of La Nina. So when we talk about La Nina, so first of all in the Pacific, what is observed? In the region of the Pacific Ocean, what is observed here is that you have warmer waters and low pressure system which develops over Western Pacific. Okay, so here low pressure system develops over the region of Western Pacific. So as we have talked about this as well, prior to this as well, that when you observe the region of the Western Pacific, there is a creation of a low pressure. And this low pressure will attract winds from all various directions. And here the wind will rise up, create a kind of a circulation, and overall observe that in the region of the mascarene high pressure, that is where you have the development of colder waters, and in the region of mascarene high pressure you have the creation of a strong or an effect which strengthens the mascarene high pressure. So in this case, sinking air sinking air in the southern or southwestern Indian Ocean strengthens the mascarene high pressure. It makes the mascarene high pressure much more stronger overall. Okay, so that is what is observed in this case. La Nina will always end up strengthening the mascarene high pressure. Now, when the mascarene high pressure will get stronger, we have seen that the driver of the monsoon winds, all the various different monsoon winds that India receives, now the genesis of it, the origin of it is experienced from the region of mascarene high pressure. So strengthening of mascarene high pressure is very instrumental. So due to heating of the Western Pacific, there is a creation of a low pressure over the region of the Western Pacific. Air rises up, forms clouds, and after that diverges from the region of the troposphere in the eastern and the western directions. The part which moves to the west eventually subsides in the region of mascarene high, thereby strengthening the mascarene high pressure. This strengthens the intensity of monsoon winds, which ends up creating more amount of rainfall. And India in general receives more than average rainfall. So India receives during these conditions, India receives or gets higher than average rainfall. I'm writing it time and time again so that it should get imprinted in your mind that you don't get confused that La Nina is associated with deficit rainfall or it is associated with surplus rainfall, higher than average rainfall. Okay, that is expected. Now, in the case of El Nino, which is also referred to as the warming phase of the Pacific. So, when you have the El Nino conditions, so here you have development of warmer waters in the region of central and also eastern part of Pacific. Now that will induce a circulation which will attract the winds, and overall observe that due to the circulation of the ocean as well and due to the air circulation as well, here you experience a kind of a rising air column, right? That rising air column, it will end up weakening the high pressure at the region of Mascarene Islands. So when the Mascarene high pressure gets weakened, the amount of winds driven towards India, that also weakens quite substantially. So here you would observe that basically it is the weakening of the Mascarene high pressure which is experienced. So due to heating of the eastern Pacific, you have a creation of a circulation. The part which moves to the west, that is towards the Indian Ocean. This is towards Indian Ocean. Okay. Towards the portion of the Indian Ocean. It induces a circulation which will weaken the high pressure system in existence in the region of Mascarene High. So this weakens the intensity of the monsoon winds, causing a shortage of rainfall. So overall, India experiences a deficit of rainfall. Now, this year, already in the month of August, we have received close to around 12% of deficit rainfall in our country. Yes, the amount of rainfall is significantly concentrated in certain areas such as Himachal, where you have the events of cloudbursts happening very recently as well. But then, basically, the overall country, if you consider, and overall country's average that you consider, that has taken a sharp dip. Okay, so that is basically in the years of El Nino and the years of such conditions of stronger El Nino, India has always experienced a kind of a drier condition, a drought like condition. But then you also have to be aware of the fact that it is not always the creation of this circulation in itself which impacts the creation of or the occurrence of more rainfall or less rainfall. Many of the times it is also impacted by the movement of oceanic waters themselves, something that we will study in a later part of tomorrow if possible. So basically, if I am to craft out the portion of equator here, now what happens in the Pacific can end up influencing. For example, right now we are experiencing El Nino conditions, a weak El Nino conditions. So that is why India has already started experiencing a deficit rainfall. But sometimes it can also happen that El Nino conditions, they are at their peak in the month of December, or La Nina conditions, they are at their peak in the month of November, December, and January, and the impact is experienced by India. So here, how does that happen and why does that happen? So basically, that is due to the movement of oceanic waters. Now, just to give you an information, which we will again, I will tell you. So please don't start panicking that what is it that he has written? Please explain this. Please repeat this. And this is just as a point of information which you will have a better clarity when we study ocean currents. We have an ocean current from the region of the Pacific which slowly ends up transferring water from the region of the Pacific to the region of Indian Ocean. And that current, ocean current, is what is referred to as the Lewin current. Lewin current. So that Lewin oceanic current, if this is not clear, let me write it out separately. You have the transfer of oceanic currents or oceanic water, that by a current which we refer to as the Lewin current. Okay. So this Lewin current sometimes slowly but steadily ends up transferring that water from the region of the Pacific to the Indian Ocean. That means very slowly in certain conditions and certain times, the warmer waters are transferred. So that creates a situation where, let's suppose you have during the conditions of La Nina, let's suppose you have the warmer waters which are present here during the condition of La Nina. This I am talking about those areas and those situations when the conditions of La Nina and El Nino, they peak during the months of November, December, January, but they end up having an impact on monsoon in the month of June, July, and August. So you have an event which has occurred in the Pacific in the month of December and January, and it is having an impact over the Indian subcontinent in the month of June and July. So how can that happen? That can happen only if these conditions of Pacific, they are replicated or they are translated over to the portion of Indian Ocean. So understand this: when you have La Nina conditions in the month of November, December, and January, basically these warm waters sometimes they are carried over and they they end up getting entrenched in the region of Arabian Sea. It takes around 6 months for these waters to get transported from the region of Western Pacific to the region of the western portion of Indian Ocean. And then when you have this low pressure created, understand that you already have the ITCZ which is passing over the Indian subcontinent. So this is the acute low pressure. Then another low pressure which gets created will act as a conduit, will act as a channel, and that will start attracting more monsoonal winds and will provide a channel for more monsoonal winds to be directed towards India. So that is how sometimes when we talk about La Nina conditions, it can have a translated impact even 6 months later. Let me clarify itself here only that in general studies, nobody is going to go into such great depths and details. Even the examiner will not go to the depths that tell me why La Nina happens in December and why it influences in the month of June, July. Mostly, or in all the questions that you will face, you'll face the question that why is it that La Nina will have an increased rainfall because of strengthening of mascarene high pressure, why El Nino will have lesser rainfall because of weakening of the mascarene high pressure. That is it. That is all that you need to know. This is just to solve the curiosity because few of you had written a mail to me as well that sometimes we experience El Nino and La Nina during the month of December. And how is it that it is going to have an impact on the Indian monsoon 6 months down the line? So that is when the La Nina El Nino conditions, which have happened during those months, they will be carried over by the portion of the ocean current. And that creates a conducive scenario or a detrimental scenario, which can always influence the Indian monsoon. Now, here, that is the scene that or the situation that we have seen in the case of La Nina. Now, let's suppose we have the El Nino. Let's suppose we have the condition of El Nino. Now, El Nino is when you have warmer waters in the region of Eastern Pacific. Now, if I ask you a very simple basic question, purely by logic, even if you don't know geography, think about it that in 6 months, water from Western Pacific has managed to travel to the region of Western Indian Ocean. So, in 6 months, these warmer waters will they be able to reach the portion of Arabian Sea or will they be left somewhere towards the east of Arabian Sea? What do you think? Very good. They will always be left somewhere to the east of Arabian Sea because it will take around 6 months. So, in those 6 months, these warmer waters from the region of El Nino, they will end up getting transferred over the region of Eastern Indian Ocean itself. And when you have the warmer waters being able to travel up till this distance, so here now you have the low pressure. Now, this low pressure is a competing low pressure. It is not a supporting low pressure to ITCZ. The earlier situation was a supporting low pressure to the ITCZ. where it supported the amount of winds moving towards ITCZ. But this low pressure across the Eastern Pacific, it is a competing low pressure. Because why? Because if you consider the masculine high pressure here, this will attract and divert some winds in this region itself. Okay, this will attract and divert the winds in this region itself, and that means you will have lesser winds moving towards the region of the Indian subcontinent. Lesser winds moving towards Indian subcontinent means you have lesser than average rainfall. So in all the cases, we have seen that La Nina is always associated with slightly greater than average rainfall over Indian subcontinent, and El Nino is always associated with a kind of deficit in terms of the amount of rainfall which is received. Then we come to the influence of Indian Ocean dipole. We have seen that Indian Ocean dipole, we have talked about it earlier itself, and many of you had these doubts and had this query which we did not resolve at that point of time, that how is it that Indian Ocean dipole can impact the Indian monsoon, how is it that the Indian Ocean dipole can counteract the effect of Indian monsoon. So let me clarify here again that Indian Ocean dipole has got the potential to counteract, right? To counter the influence of Enzo or El Nino La Nina conditions, there is the impact of Indian Ocean dipole. It can either exaggerate the role of El Nino La Nina or it can counter them. So, we had seen that you had three different phases of Indian Ocean dipole. You had a normal phase or a neutral phase, then you had a positive phase, and then you had a negative phase. Okay, these three conditions we have seen that Indian Ocean dipole experiences these three basic conditions. Now, here, let us understand what happens in all these cases and how it will have the potential to impact the amount of rainfall received in Indian monsoon. So, here we have the mascarene high pressure, which is the driver of the winds. Mascarene high pressure. Here we will have the ITCZ. During the month of June, July, here is where the ITCZ lies. Now, when we have the case of the positive Indian Ocean dipole, positive Indian Ocean dipole means where is it that the warmer waters will be? Western part of Indian Ocean or eastern part of Indian Ocean? Where is it that we will have warmer waters? Very good. Western part of Indian Ocean. So all the warm water in this case will be present here. You will have a low pressure. Now, when you have a low pressure here, basically this acts as a channelization in the sense that it will pull in more winds from the region of the mascarene high, right? More winds will be pulled here. And when you have the surplus of winds in this region, they will be attracted towards the ITCZ after that. So it ends up behaving like a supporting low pressure to the ITCZ. So positive phase of Indian Ocean dipole acts as a supporting phase for ITCZ. Means will attract more winds, and when you have more winds which will come, that will induce a circulation, that is greater rains in India. So that is why Positive IOD is always associated with the case of greater amount of rainfall. It can happen, as it has happened prior or earlier also, that the condition of positive Indian Ocean dipole has been in existence simultaneously with the condition of El Nino. Now, while El Nino is supposed to reduce the amount of rainfall, positive IOD is supposed to increase the amount of rainfall. Now, what actually plays out in reality is that while El Nino will weaken the high pressure zone in the Mascarene region, but this low pressure which gets created in the region of the Arabian Sea, that pulls in all the winds from the surrounding areas and sends it over to India. So, in a way, it is a kind of a counterbalance or a counter force. But then sometimes you have this positive IOD, which coincides with the condition of La Nina. Now, both of them are supposed to bring higher rainfall. So that always results in much higher than average rainfall received over the Indian subcontinent. And it is in these conditions and these cases where you will find that the region of India and the Indian subcontinent ends up receiving much greater or almost 109, 110% of the average expected rainfall. Okay. Now, then, after that, what happens during normal and negative phase? In the normal and negative phase, where is it that we have the warmer waters? In which portion of the Indian Ocean do we have the warmer waters? Good, eastern. So, warmer waters or low pressure develops in eastern Indian Ocean. Okay, the low pressure develops in the region of eastern Indian Ocean. So when you have the low pressure which develops over the region of eastern Indian Ocean here, now think about that scenario. Let's erase the first one and let's think about the other scenario. Now when you have this low pressure which develops here, then what happens? Now ideally, this mascarene high is supposed to provide winds to the region of the Indian Ocean, to the region of the Indian subcontinent. Ideally, that is supposed to happen, right? But then you have a competing low pressure here. So this competing low pressure, it will attract winds from the region of the high pressure. The nearest high pressure is the mascarene high. So it will start attracting winds from this area. Now, if winds get attracted towards this low pressure, obviously the amount of winds getting generated towards the Indian subcontinent, they will start to reduce, isn't it? So the amount of winds, they will be redirected towards the region of the Eastern Indian Ocean. And that means lesser amount of winds coming over to the Indian subcontinent. When you have lesser amount of winds coming to the Indian subcontinent, always means lesser amount of rainfall, isn't it? So here, this is a competing low pressure. Low pressure. So when you have a competing low pressure, that means what? Diverts winds from mascarene high. Okay, means lesser winds to Indian subcontinent, which means lesser than average rainfall. Now, if you have Stronger low pressure here, if let's suppose this low pressure is very strong, that means what? It will end up attracting more amount of these winds, isn't it? It will begin to channelize more amount of these winds. Now when you have more winds which are channelized in that direction, means what? It basically means that lesser rainfall, further lesser rainfall. So stronger the low pressure in the eastern Indian Ocean means weaker monsoon. Now in the case of negative and neutral IOD, when is it that we have a stronger low pressure in the region of the eastern Indian Ocean? In the case of the normal or negative, when is it that we have a stronger low pressure? Very good. It is in the case of negative. So that is why negative will all phase of Indian Ocean dipole will always bring much lesser amount of winds towards the Indian subcontinent, much lesser amount of rainfall towards the Indian subcontinent. Okay. Now, then we come to the entire mechanism of southwest monsoon. Now, this southwest monsoon, this is also what is referred to as the advancing monsoon. Advancing monsoon. Why is that the case? Why is it referred to as the advancing monsoon? That is because when we talk about this particular portion of monsoon and the monsoonal winds coming, we have seen that how ITCZ slowly and steadily starts covering the portion of the Indian subcontinent. We have taken a look at that. That initially it comes to the southern part of the country and slowly and steadily it reaches to the north and it covers the entirety of the Indian subcontinent. So, because slowly and steadily the entire Indian subcontinent is covered and the ITCZ advances towards the Indian subcontinent, bringing the winds from south to north, hence the name advancing monsoon. So, winds will always be driven from the region of the south to the region of the north. From the time of the onset of monsoon, it takes about 1 month for the winds to cover the rest of the country as well. So that is why the name advancing monsoon. Now, in the case of advancing monsoon, direction of the winds is southwest of winds is southwest to northeast. Okay. So that is the direction of the winds. And which winds are these? When we talk about these winds, we have talked about it earlier as well. So which are these particular winds that we are talking about? Beautiful. It is the southern trade winds that we have. That is what changes direction after crossing the portion of the equator. Okay. So here, let us take a look at the mechanism in itself. That how is it that the entire mechanism is driven about? So when we talk about the mechanism here, understand that basically you have the situation where initially as the summer season comes in, so at the time of March, around 22nd of March, we have 21st 22nd of March, we have the condition of equinox. That is where the sun is supposed to prevail over the region of equator, the positioning of the sun, and the positioning of the sun is going to advance towards the region of the tropic of Cancer up till 21st of June. Then again the position of the sun starts retreating. It comes over the region of equator again. When is it that the sun will again come over the region of equator? September. Very good. So again the sun comes over to the region of equator. So as the sun advances, with that the heating also starts to happen. You already would have experienced that since the month of mid to late March itself, the land starts to get very, very hot. It starts to bake almost. It gets very, very hot. So when the land starts getting very hot, the temperature starts to rise. You would experience that the temperature in the northern part of the country, particularly around the region of Rajasthan, the northern plains, etc., the continental areas, there the temperature anyways gets into the range of 45 degree plus. So that creates a very intense low pressure. ITCZ we know is the thermal low pressure. So the ITCZ translates over to the Indian subcontinent here. Here. This is where the ITCZ comes in. Now, once the ITCZ comes in this direction, it will start attracting winds from the Hadley cell, the subtropical southern subtropical high pressure belt, or the high pressure zone that is present around Mascarene Islands. So that high pressure zone, which is created around the Mascarene Islands, this will start driving the winds. This will start pushing the winds, and the winds are basically getting attracted towards that low pressure or the ITCZ. Now here, the winds, they reach here due to the shape of the Indian subcontinent, they get diverged. Then here you have a chain of mountain systems. That is the Arakan Yoma, Pegu Yoma, and the Tanaserim mountain ranges that you find across the region of Myanmar. Now these mountain systems, they will also divert the winds ever so slightly. But till now, rainfall will not happen. You won't experience the occurrence of rainfall at this point of time. And why is that? Why is it that the rainfall will not happen despite the ITCZ shifting? Beautiful. You have the southern branch of the subtropical jet stream, which is still going to move over the region of the Indian subcontinent. So, as long as the southern branch of the subtropical westerly jet stream exists, there will be no movement of air over the Indian subcontinent. The air will lie pretty much static. And that is when suddenly in the later part of May, you will start experiencing very high amount of temperature. Sometimes even in the first week of June, you will start experiencing very high amount of temperature range. So when you experience very high amount of temperature range or very high amount of temperature in general, what happens as a consequence of that? So as a consequence, you will have more winds which are carried. So the winds, they are unable to move over the region of the Indian subcontinent because of the prevalence of the subtropical westerly jet stream. So there cannot be occurrence of these trade winds induced rainfall. There can be some localized rainfall created due to localized convection, but the large scale monsoonal phenomena will not happen. So no rainfall and continuous heating. So the temperature starts to rise up. And then, eventually, one fine day, the subtropical westerly jet stream weakens, and then disappears. The moment it disappears, that creates a vacancy even in the upper air. And suddenly, you'll find that the winds are driven, the winds are getting attracted upwards as well, forming many layers of clouds. Okay, I will not get into the depth and the detail of the various different atmospheric circulations induced at this point of time, but you have multiple layers of low pressure created, and that induces a kind of a convection even in the middle atmosphere, even the upper troposphere, even near the ground surface. That creates very intense cumulonimbus cloud formation. Now, these will first of all hit the Kerala coastline. When the Kerala coastline is hit by this, when the Kerala coastline is impacted by this, then what will happen? What will be observed is intense rainfall will be observed in the region of Kerala coastline. And that is what we declare as the onset of monsoon. So the onset of monsoon is always linked with the portion of the disappearance of the southern branch of the jet stream. Okay, that is where the onset will happen. Okay, now what happens after the onset? How is it that the rainfall is distributed? Let us talk about that. So, distribution of rainfall. So this happens with the disappearance of southern branch of jet. subtropical westerly jet. Okay, that will happen with the disappearance of the southern branch of subtropical westerly jet here. So that is when the onset happens. So the winds which basically have gotten up till here, they will start moving. Why? Because all of them are getting attracted towards the low pressure. The winds which have diverged and diverted up till here as well. So, first of all, they will hit the Western Ghats. So, initially, they will hit the Kerala coastline. Within a week, they will hit the Maharashtra coastline as well. So, it takes around a week for the winds to translate from the region of the Kerala coastline to the region of the Maharashtra coastline. Now, here, meanwhile, in the region of Bay of Bengal, the winds which are coming after covering all these oceanic areas, these winds they will enter through the region of Bangladesh. Now, after they have entered through the region of Bangladesh, first of all, they will hit the mountains here. Now, after hitting the mountains, first of all, they will cause immense rainfall here itself, but the winds will further get diverted. One portion goes to the northeastern part. Now, as the winds they are diverted due to the physiography, due to the topography into the western part, the or rather the northeastern part, they will receive very heavy amount of rainfall. The northeastern region receives very heavy amount of rainfall. Why? Because of the funnel shape created by the physical features. So that will trap the winds in that region, not allow the winds to go anywhere else. So this is an area which receives very copious amount of rainfall. Very high amount of rainfall is induced. Now, after that, these winds they start moving here because the northwestern part of India by that point of time, that is Delhi, Rajasthan, Punjab, they already would have started experiencing 47, 48 degrees Celsius. Meanwhile, here you will also find the presence of the region of Vindhyas and Satpura. The Vindhyas and the Satpura range. Now, in the region of the Vindhyas and Satpura, as the winds they come over, they get channelized in between this pathway. So, in this pathway, as they get channelized, you will have substantial rainfall in the portion of central India. Now, if I ask you, what about this region, this area? Will that receive rainfall or will that be dry? What do you think? Very good. That region will be dry, beautiful, because of being in the leeward side, the rain shadow zone of Western Ghats. That is why that area will be significantly drier. However, there are certain exceptions. For example, if you consider the city of Nashik, if you consider the city of Pune, if you consider the city of Bangalore, now these are the exceptions where, despite being on the leeward side, they experience rainfall. And that is because of certain gaps, Thal Ghat, Bhor Ghat gaps, etc., which is present in the Western Ghats. So that will allow the movement of the winds. Otherwise, these are the areas which lie on the rain shadow zone and the leeward side. And we have discussed already, ever since we have been discussing the portion of Chinook, Phone, etc., that how the leeward side, in the case of orographic rainfall, will always be dry, and the leeward side will always receive very little amount of rainfall, isn't it? So, other than these particular cities, these particular aberrations, there will be dry condition. So, one part of this Arabian Sea branch will basically hit the western coastline. One part of the Arabian Sea branch will move over to the portion of central India. And then one part of this Arabian Sea branch will further start its movement towards the northwestern side. Now, as that movement towards the northwestern side happens, it will move parallel to the Aravalis, right? It will end up moving parallel to the Aravalis. So while it will cause some amount of rainfall in the southern part of Aravali, where they will face or form some obstruction. And in the case of the western part of Aravalis or western Rajasthan, there is no obstruction created, no orographic obstruction created, so the winds will continue to move over. Now, as the winds are moving over, the part of the Bay of Bengal branch of monsoon, they will end up interacting with this wind, and that is where sometimes even in the eastern part of Rajasthan they will cause rainfall because the moist winds they are meeting. Otherwise, all these winds will hit the Himalayan foothills and they will end up creating a lot of rainfall. Now when you have these moist winds, they are driven by the movement or driven by the ITCZ. So as a result, all these winds, they will be attracted towards the Himalayan foothills with great intensity. And the Himalayan foothills being very, very steep, we know that Himalayan foothills we will study in greater detail later on in next week, that when we talk about the Himalayan foothills, they represent a kind of a very steep mountainous formation. So, in the case of a very steep mountainous formation, these winds will start rising up. So, when the winds are suddenly driven up, what happens? These winds, they will end up forming clouds, and a continuous movement of these winds will lead to what phenomena? Good, Abhijit. Very good. Yuvraj, Anurag, Brindavani, Avni, very good. It will lead to events of cloudburst. That is why when these moist winds they hit the southern portion or the southern face of the mountains, they cause copious amount of rainfall, and in many of the events and incidents they can end up causing cloudbursts. So that is why the region of the area of Himachal Pradesh, the area of Uttarakhand, they are frequented with cloudburst events. Another region which is very much frequented by cloudburst is the northeastern stretches and the region of Sikkim. That is because of the wind suddenly crashing with the Himalayan mountain range. Okay, this is how the entire coverage of or distribution of rainfall happens during the advancing monsoon. Now, a couple of things. What do you think will be the amount of rainfall during this time in the region of the Coromandel coast or the Tamil Nadu coastline? Do you think the Coromandel coast or the Tamil Nadu coastline will receive rainfall? No, it will be dry. Why? Because during these months, when you have the movement of these winds, the winds are parallel to the Tamil Nadu coastline. And the Arabian Sea branch of monsoon, it is not able to cause rainfall across the Tamil Nadu coastline because the Tamil Nadu coastline lies on the leeward side. So that is why it won't be able to cause any amount of rainfall in the process. So that is the phenomena. It will end up reaching the portion of Jammu Kashmir. These winds will reach the portion of Jammu Kashmir, will cause rainfall there. What about the region of Ladakh? Do you think Ladakh will be able to receive rainfall in that case? No. It will receive very little amount of rainfall. Why? Why? Leeward side. Very good. It is on the leeward side of the ranges of the mountains. So it is because of the Ladakh is present on the leeward side in the rain shadow zone of the mountains, that is the Himalayas. That is why Ladakh ends up being drier. However, the region of Jammu Kashmir, the region of entire valley, they will receive copious amount of rainfall. Okay, so this is the aspect of the rainfall distribution. Now, in this, when we say the amount of rainfall and the rainfall variation, so can we say that the amount of rainfall will reduce from south to north? Will that be a correct statement to make? Yes? Perfect. Because the moisture is lost in the process. Perfectly put. Now, can we say that the amount of rainfall reduces from east to west? Can we say that? Yes, we can say that. Because in the east, you have more moisture, and as you move away from the source of moisture, the amount of rainfall will reduce. So the amount of rainfall reduces when you move from south to north, and then when you move from east to west. The amount of rainfall happens to reduce substantially. Now, once the onset has happened, after that, many of the times, you have the development of the tropical easterly jet. Now, this tropical easterly jet, when it comes into play, now every year it won't have the same force, it won't have the same strength, because every year you don't have the Tibetan highlands getting heated to the same extent. It might be possible that in the previous year, in the month of December, January, there would have been so much of snowfall and ice over the region of Tibet that substantial amount of heat of the summer is consumed in melting of ice itself. So every year, the Tibetan highlands won't develop a very intense low pressure. However, when we talk about this Tibetan highland, now, the moment this Tibetan highland gets significantly heated up, that is when it will generate a very substantial low pressure. And that substantial low pressure will strengthen the tropical easterly jet. And this tropical easterly jet, in return, strengthens the mascarene high pressure. So this makes the high pressure at Mascarene Island stronger. Now, these are high altitude winds. Tropical easterly jet is not a surface wind. It is a high altitude wind moving at the level of the tropopause. Okay, almost at the level of tropopause. These are those winds. So let me write that down as well. These are high altitude winds moving at tropopause. Okay, moving at the region of tropopause. So they won't be interrupting the movement of winds over India, the surface winds that we have been talking about. So these don't interact, do not interact with surface winds. The subtropical westerly jet, however, that is much more stronger. That is what, or that is also at the lower level. So that is why it will have a greater interruption for the surface winds. And these winds, they will be the subtropical westerly jet we have seen moves somewhere in this direction. Whereas the tropical easterly jet, this is a wind which moves in this direction. So that is why it won't have much of an interference. So when the mascarene high pressure gets stronger, means more winds are driven towards the Indian subcontinent. Okay. More winds are driven towards the Indian subcontinent in general. Then the impact of El Nino and La Nina we have already seen. It will end up impacting the creation or the existence of the mascarene and the high pressure. So El Nino will weaken the mascarene high, La Nina will strengthen the mascarene high, and that will impact or make the Indian monsoon stronger or even slower. Then Indian Ocean dipole, it can interfere with the influence of the Enso cycle, Positive IOD will strengthen the Indian monsoon by acting or creating a supporting low pressure to the ITCZ, whereas the neutral and negative IOD, they will influence or have adverse impact over the Indian monsoon by diverting the winds from the region of the masculine high pressure. So that is where you have the impact of the IOD as well. It can counter the impact of the Enzo phenomena, can counter or exaggerate the impact of Enzo phenomena over Indian subcontinent. Okay. Now, after this, we come to the portion which we talk about the retreat of monsoon. Now, something which advances will also eventually end up retreating, right? So we have the advancing monsoon. So that is how we also come across the fact of monsoon is basically, in the simplest of the terms, the southward march of the ITCZ. Because we have seen that after 21st of June, 21st, 22nd of June, we do know that the southward movement of sun begins. And by the time of 23rd September, you have the sun over the region of equator. And then 21st of December is when the sun will come to further south in the region of Tropic of Capricorn. We have seen and covered that particular movement. So as the sun starts moving southwards towards the region of equator, the ITCZ also significantly shifts along with that. So you have the withdrawal of the ITCZ from the Indian mainland. And when that withdrawal of ITCZ starts to happen, what will happen to the winds? So earlier, let's suppose the ITCZ was here. The winds are attracted up till this direction, up till this portion. Let's suppose the ITCZ has come here. The winds will be developed only up till this region. And simultaneously, you will have the setting up of the other northern trade winds as well. As the ITCZ comes over here, the wind system will be restricted only to this portion, isn't it? So overall, you have the withdrawal of ITCZ from the Indian subcontinent due to the southward movement of the sun. And that is when the wind system also, they will be restricted. They will start withdrawing the moist winds. They will start withdrawing from the region of the Indian subcontinent. So this is basically withdrawal of ITCZ over from the Indian subcontinent. Okay, withdrawal of ITCZ from the Indian subcontinent, and then moist winds, bearing winds also start withdrawing. So that is referred to as the retreat of the monsoon. Now, generally, it is initiated, this is just for your information. Generally, this gets initiated around 17th of September. 17th of September, somewhere around that time, you will observe that the ITCZ, till that point of time, it would very much pass over from this area. But around 17th of September, you will observe the ITCZ to start to withdraw. It will start its southern and southward march. Now, after that, it takes close to around a month and a half, or sometimes even 2 months, for that withdrawal process to happen. So that entire withdrawal process that happens, or that takes place over the span of 2 months, happens over the span of 2 months. Okay. So during this time, as the ITCZ starts to withdraw, its destination is equator, and depending upon the solar movement, it will also end up moving south. So the ITCZ, as it withdraws, let's suppose it is here. Now, the wind system will be restricted over to this portion, and the northern part of the trade winds, northern Hadley cell, which was interrupted earlier during the time of the advancing monsoon because of the obstruction by the Himalayas. So those northern trade winds that will also start setting up. So those northern trade winds, they set up. Now most of these winds, you will find that they are originating and moving over from the landmass, isn't it? You will observe they are originating from the landmass. So these winds, will they be able to cause rainfall? All these winds, will they be able to create or cause any amount of rainfall? No, because they are moving over the drier landmass, so they won't have moisture. However, you have certain winds which move over to the region of Bay of Bengal, and after that they hit the Tamil Nadu coastline or the Coromandel coastline. Now, that is when these winds will bring sufficient amount of rainfall across the Coromandel coastline. So, at the time of the retreat of the monsoon, Coromandel coastline or Tamil Nadu coastline starts experiencing significantly higher amount of rainfall. So, that is when Tamil Nadu coastline receives rain. Nadu coastline receives rainfall. Now, what is the general direction of wind movement? Over these months, what is the general direction of wind movement? Northeast to southwest, we can say, isn't it? The general direction of wind movement is from northeast to southwest. So it is a reversal of the wind which Indian subcontinent experienced. So that reversal of wind, monsoon. Now, for the rest of the country, which are going to experience a lack of rainfall. Now, if I tell you that since the month of June, July, August, September, the portion of the country will be experiencing rainfall. Okay. So that portion of the country, the entire portion of the country would receive rainfall. So by the time of October, what do you think will be the level of moisture in the air? I'm not talking about rainfall. The level of moisture after receiving 2 to 3 months, 4 months of rainfall, moisture level will be high or will it be low? It will be significant. You will have significant amount of moisture level by the month of October, right? It will not be very, very dry. Okay. So when you talk about those particular areas, now in those areas during the month of October, you won't receive rainfall because you don't have the low pressure. So no rainfall, but moisture is going to be prevalent. So what do you think will be the amount of heat experienced? If the moisture is high, no rainfall, but what will be the heat? The heat will be high because the moisture will retain all that heat, isn't it? So that is the condition which we demarcate as October heat. When the temperature is not very high, temperature is pretty much lower than the summer conditions. But due to lack of rainfall and prevalence of moisture, the conditions in the inland areas, they start becoming oppressive. So that is referred to as the condition of October heat. Okay. Now, if I ask you that in the portion or in the entirety of this monsoon phenomena, which is the portion of the country where the monsoon reaches last and withdraws first? Which is that portion of the country where the monsoon reaches last and withdraws first? It is going to be the northwestern part. Northwestern part is the portion where, that is Punjab, Haryana. In these areas, the monsoon has reached last, but then the retreat has been initiated from the region of the northwest part itself. Tamil Nadu will receive rainfall or monsoon winds at the later point of time as well. But then it is in the region of Punjab, Haryana, where the northwestern part of the country is concerned. That is where the monsoon is going to reach to the last and is going to withdraw at the earliest. Okay. So that is basically the occurrence of rainfall and the distribution of rainfall pattern. When we talk about the Andhra coastline and the Odisha coastline will receive some amount of rainfall with the advancing monsoon itself. Okay, that is where Odisha coastline will receive rainfall. Southern part of Andhra coastline will receive rainfall along with the Coromandel coast. Okay, now this is something which happens from the month of September to at max November. Generally, it happens for 1 month, but sometimes it gets stretched. So, September to at max November is when you will experience this phenomena. Then after that, so observe this particular image. Here you have the retreat or the withdrawal of the ITCZ and the low pressure. So observe how the low pressure, it starts withdrawing. So on 1st of October, it will be here. 15th of October, it will be somewhere here. 15th of November, it will be somewhere here. 1st of December, it will be somewhere here. So that is how the entire withdrawal takes place. It is during this process of withdrawal that the low pressure also does happen to lie over the region of Bay of Bengal and does happen to lie even over the region of the Arabian Sea. And that creates a substantial event or a phenomena of creation of a cyclone. So that is when, even in the month of November and December, despite the country experiencing low temperature, you will have the Bay of Bengal and Arabian Sea sometimes forming the cyclonic circulation. Okay. Now, then in the later part of November, and then in the month of December, and sometimes even in early part of January, you have the development of a wind system, which is also regarded as the northeast monsoon. Many of the textbooks you will find that the portion of retreat of monsoon and northeast monsoon, they are given in the same manner. They are said to be the same thing. But if you refer to the portion of the Indian Meteorological Department website, it differentiates that northeast monsoon is a different phenomena and withdrawal and retreat of monsoon is a different phenomena. So before moving into the northeast monsoon, I will again repeat what do we understand by the retreat of monsoon. Retreat of monsoon is different from northeast monsoon, even though the wind characteristics might be very same, but it is a different phenomena because retreat is the process of withdrawal. That process of withdrawal which happens for the span of 2 months, that is what we refer to as the retreat. But after that, what sets in, that is the northeast monsoon. So here Tamil Nadu coastline will receive rainfall both during the retreat as well as in the northeast. So this happens in the month of December, January. So during this time, the ITCZ will be firmly set over this particular area. This is where the ITCZ will be, let's assume, right? Just for your reference pointers. Now, what do you think will be the temperature condition if I show you these areas which are in Pakistan, what is referred to as the Potwar Plateau? So, if you refer to these areas, what do you think will be the temperature during the months of late October, November, and December? Very low. very, very low temperature. So it will create a kind of a high pressure, isn't it? Some amount of high pressure will be created. So here you will have a high pressure zone at the region of the Potwar Plateau. Now this will start driving the winds. Winds will be diverting and deviating to the left as well, or to the right, owing to the Coriolis force. Now, which are these winds that we are drawing here? What are these winds known as? Please let me know. Trade winds. Very good. These are the northern trade winds in itself. Now, these wind systems, they will again cross the portion of the Bay of Bengal and will start hitting the Coromandel coastline. So, when they hit the Coromandel coastline, what will be the condition? Rainfall will be received. High amount of rainfall will be received over the Coromandel coastline. So when we talk about northeast monsoon, so here why it is named as northeast monsoon? Because the direction of the wind is northeast to southwest. Direction of wind motion, of wind movement, is northeast to southwest. Hence the name northeast monsoon winds. All the winds are going towards ITCZ, isn't it? And this will bring rainfall, brings rain in Coromandel coastline. Okay? They will be bringing substantial amount of rainfall in the region of the Coromandel coastline. Okay, so that is what we refer to as the northeast monsoon winds. Okay, now this will generally get established after the withdrawal of the monsoon, after the retreat of the monsoon. That is when it gets set up. So gets established after the monsoon or withdrawal of monsoon. So after the withdrawal of monsoon, once the ITCZ settles around the region of equator, that is when you will observe the reversal, complete reversal of these winds, and that is where these winds will be blowing over to the region of the Indian subcontinent. The inland areas will be dry. The Coromandel coastline will receive rainfall. That is the entire phenomena. So in this entire phenomena, you would have observed that the wind movement has come in, advanced over the Indian subcontinent over a month. From the month of September, 17th September onwards, you'll find the general retreat of the ITCZ, that is the retreat of the monsoon. Once the ITCZ further ends up getting into the region around the equator, that is where you have these perpetual wind, that northern trade winds, which become dominant, and that is the northeast monsoon. Okay, now then we come across what is referred to as break in monsoon. Now sometimes it can happen that, or you would also have observed that in your region, after a particular span of intense rainfall, your region experiences very dry conditions. There is no occurrence of rainfall there, right? So you would have found out, or would have experienced, that you have 4 to 5, 6 days of continuous rainfall, followed by 7 to 10 days of dry condition. Now, once the onset has happened And then you have 7, 10, 12, 15 days of very dry conditions which follows before the next span of rain. That is what is referred to as a break in monsoon. So why does that break in monsoon happen? And understand the reason. The reason is very simple here. I will take the help of a particular map, any of the map. I'll take the help of this map. Don't get confused while carrying out revision. So let's suppose the monsoonal winds, they are driven towards the region of the Western Ghats. Let's suppose. Now, the Western Ghats, they are getting driven towards this, but the winds are actually trying to reach the ITCZ. That is the low pressure. They have gotten bent and deviated because of the Coriolis force, and they're bound to hit the region of the Western Ghats. Now, let's suppose in this area, the monsoon winds are hitting. They are causing very heavy amount of rainfall here. But due to intense heating, let's suppose there is a very significant low pressure cell which has formed here. So the existing winds, they will be diverted towards the low pressure. The existing winds will be diverted towards the low pressure. What will happen to these stretches now? The Goa coastline, southern Maharashtra coastline, Karnataka coastline. What do you think will happen to those areas? Will they receive rainfall in that case? Or will they not receive rainfall? No rainfall. Why? Because the winds have started blowing almost parallel to the Western Ghats. So there will be no orographic rain. So that is the region where you will, or that is the reason why many of the times you have a prolonged dry season, because maybe a competing low pressure has developed. But this is also something which is observed in the plain areas. It is not only restricted to the mountainous regions. So in the plain areas, what happens? Let's suppose you are in the region of, let's suppose, Chhattisgarh. Now, Chhattisgarh has got the low pressure. A low pressure cell has developed, a part of, let's suppose, the ITCZ. So all the winds from this region will get attracted towards this low pressure. They will cause substantial amount of rainfall in Chhattisgarh. And meanwhile, UP and those areas, they are not receiving rainfall. MP is considerably drier. Now, in all these areas where you are continuously receiving rainfall in Chhattisgarh, what will happen to the temperature? After, so recall it from your own experience. After it rains continuously for, let's say, 1 week or 10 days, what happens to the temperature? The temperature goes higher or the temperature goes lower? You will have a low temperature. Meanwhile, as the temperature here gets colder, meanwhile, let's suppose you have a region here which has not received rainfall for a very long time. So this will be a more activated low pressure, whereas this will get converted into a comparative high pressure. So now this area won't be experiencing rainfall. This area rather would be supplying winds, and more winds would be driven from here. So this region, which had earlier received continuous rainfall, will now experience dry conditions for a long time. And that is something you would have experienced. You would have experienced it, you would not have noticed it. But now, if you notice it, that after 4 to 5 days of continuous rainfall, generally you have a dry phase, because that region cools down, converts into a comparative high pressure. Maybe your neighboring area becomes very hot, and that starts getting more rainfall. So that is the impact, or what we refer to as the break in monsoon. So after rainy periods, if the rains fail to occur for more than 1 or 2 weeks, it is known as the break in monsoon. Dry spells are quite common during the rainy season, and breaks in the different regions are due to various areas. So in northern India, rains are likely to fail if the rain bearing storms are not frequent and the rain bearing storms are diverted towards another high pressure. Over the west coast, the dry spells are associated with days when the winds blow parallel to the coastline. So that is why you have these dry conditions. However, before the onset of monsoon, you do have some amount of periodic rainfall, which is experienced especially in the coastal areas and the areas closer to the coastline. You do experience some amount of rainfall even prior to the onset of monsoon. So that rainfall is not a part of the monsoon rain. That is what is referred to as the pre-monsoon showers. Now, these pre-monsoon showers, they are basically convectional rainfall in a manner. They end up creating convectional amount of rainfall because of intense heating of the landmass and the sudden substantial difference of temperature between the land and water. So that ends up creating the pre-monsoon shower. It is known by different names in different parts of the country. For example, in the region of Kerala and the coastal areas of Karnataka, it is referred to as mango shower. So towards the end of the summer, these are the pre-monsoon showers. They help in early ripening of the mango. These are basically convectional in nature. In nature. Okay, which kind of clouds will get created by this? By this rainfall that we receive. What kind of cloud formation will we observe in this? Good. Cumulonimbus. You will observe cumulonimbus kind of cloud formation in general. Stratus won't be observed here. Then you have the nor'westers, or what is referred to as Kal Baisakhi. Now, this is something observed in the region of West Bengal, some portions of northeastern coastal Odisha, and some portions of Assam, even in Bangladesh. Now, these happen in the month of Basak, and these are always associated with very dark cumulonimbus clouds. And when you have these dark cumulonimbus clouds, you will have frequent occurrence of very strong wind movement, along with thunderstorms, lightning, sometimes even hailstorms. So that is why the name Kal Baisakhi. So here it is also known by Bardolisira in the region of Assam. So it is referred to by different names. So here it is the dreaded evening thunderstorms. Notorious nature can be understood from the local nomenclature, that is Kal Baisakhi, a calamity in the month of Basak over the region of Bengal, Assam. Now, these showers are useful. So, these are the showers which happen prior to the onset of monsoon. So, these showers are helpful in the cultivation of tea, jute, and also rice. They are also referred to as Bardoli Sira. So, because when we talk about jute, jute also requires significant amount of accumulated water, and lot of rainfall is required by jute. So, they require rainfall prior to the monsoon, during the monsoon, and even after the monsoonal months. Okay. Now, then we come to the winter season. What happens and what actually goes on during the winter months? Now, during the winter months, is when. So, pre monsoon showers will occur in the month of April and first part of May. That is when the pre monsoon showers will occur. Okay. Now, the winter season over the country is experienced during the months of November, December, January, February. Now, during that period of time, the ITCZ lies around the region of equator, slightly to the south of equator. That is where the ITCZ lies. Now, as the ITCZ lies, let's suppose I draw the ITCZ. Let's suppose I draw it somewhere here during this month. Let's suppose. Or let's have a kind of a uniform movement of ITCZ for some time. This is your equator. Now, the subtropical high pressure belt of the northern hemisphere, will it stay in the same place as earlier, or will it move south? Will it move north? What do you think? The subtropical high pressure belt in the northern hemisphere, what will be its movement? It will move south because the ITCZ has moved south, so the pressure belt will also move south. So, otherwise, on an average, the subtropical high pressure belt lies at which latitude? on an average? At which latitude do we find the subtropical high pressure belt? Very good. At 30? At 30° north and south, that is where the subtropical high pressure belt lies. So when it moves south, it will move somewhere around 25 degrees. That is why the entire range we consider 25 to 35. So when it moves south, it comes somewhere around the region of 25 degrees, 23 degrees as well. So here, the movement of wind pattern over India will be what? In the northern part of India. I'm not talking about the southern part of India. So the movement in northern part of India will experience which wind movement? Westerlies, because originating from the subtropical high, the northern part of India will experience westerlies. The southern part of India will be experiencing the trade winds, isn't it? Now, understand another concept. Over the region of Mediterranean during these winter months and during these winter season, the temperature of the sea in the Mediterranean and the temperature of the land, which will be warmer, or will they have equal temperature? What do you think? Which will be warmer during the winter months, or will they exhibit a same temperature? Mediterranean will be warmer, perfect. The sea will be warmer. So the sea has got warmer air. Land has got cold air. Now, can we say there will be a frontal creation in this portion? Can we say that there will be creation of a front? And because it is a water body, the rise of air will also end up causing a kind of a frontal creation. You have the rise of air creating that low pressure. Can we experience a frontal disturbance or a frontal low pressure, a kind of an extratropical cyclonic development we can experience? Isn't it? So here you will have the mixing of the cold air and the warm air, creating a front and thereby creating a kind of a low pressure disturbance. So that will have clouds, etc. Now, these low pressure, including the formation of clouds and everything, what will be their general course of movement? Will they end up staying over the region of Mediterranean? Will they end up moving north? Will they end up moving south? Will they end up moving west? Will they end up moving east? What do you think? They will move eastwards. Why? As an influence from the westerlies. So they will be these disturbances. They will be influenced by the westerlies and they will move further to the east. These disturbances will start traveling. As the disturbance travels, another disturbance develops that will also travel. So this will end up traveling. So it will travel until it hits the Himalayan foothills. That is the major obstruction it faces. So these disturbances will cross the region of West Asia, that is Iraq, then it will cross over Iran, portion of Afghanistan, Pakistan, and then it will reach India. Upon reaching India, it encounters the massive boundary in the form of Himalayas. And when they hit the Himalayan foothills, they will cause rainfall in the region of Punjab, in the region of Haryana. So here they will start causing rainfall in the region of Punjab, Haryana, western UP, in fact, the plains of UP, sometimes northern portion of Rajasthan, plains of UP. If the westerlies are strong enough, plains of Bihar. If the westerlies are even strong enough, even in the region of the portion of Assam plains as well, northern Bengal and Assam. Okay, but in the region of the Himalayan foothills, they will cause snowfall. And also in the heavy reaches or the higher reaches of Himalayas, they will cause snowfall. Why? Because of altitude. Now, these are disturbances or low pressure disturbances which are traveling from west to east. So that is why these disturbances, they are also referred to as the western disturbances. They end up causing rainfall during the winter months in Punjab, Haryana, Delhi, northern Rajasthan, because it is a traveling low pressure. So it will end up causing rainfall even in Uttar Pradesh, that is the northern stretches of Uttar Pradesh, sometimes even in Bihar, sometimes even in West Bengal, and as far east up till Assam. Whereas in the region of the Himalayas, it will cause heavy snowfall. So these western disturbances overall, they are low pressure systems which originate over the Mediterranean Sea and Western Asia and move into India along with the westerly flow of the winds. So they are referred to as the western disturbances. They cause the much needed winter rains over the plains and snowfall in the mountains. Although the total amount of the winter rainfall locally in these areas, it is referred to as Mahavat. Although the amount of rainfall caused is not very significant, but that rainfall is very important for the sowing of the wheat crop, mustard crop, and in general the rabi crops. Right? Example, wheat and mustard. Example, wheat and mustard. Okay, so that is why they are referred to as the western disturbances. Basically, these are your disturbances which travel over. So they start happening since the month of November, when you will have 3 to 4 such disturbances which come. In the month of December and January is when they peak. Why? Why will the western disturbances peak during the month of December and January? Very good. Temperature gradient is very high. In the month of February, again 4 to 5, March 2 to 3, April. Now, earlier it used to be restricted only up till the month of February. Maybe in the month of March, you would receive one or the odd incidents of these Western disturbances, but they would be drier. So, but now, this year, we have experienced these disturbances to have come even up till the month of July, and that is a rare aberration. Why it has occurred this year, even up till the month of July, is that is why this year you would have experienced that Jammu Kashmir, the region of Himachal Pradesh, they have been receiving snowfall as late as the month of May, whereas those are not the months where they receive snowfall. But this year they have received snowfall even up till the month of May. So why is it happening is because of global warming and climate change. Different areas, they are getting heated and cooled down to different proportions. As long as you have a difference in temperature in the northern area and the tropical region, as long as the difference in temperature exists, you will have the frontal creation. Frontal formation will also exist. And that frontal formation, as it exists, it can always give rise to these disturbances and the circulations. That is why this year in the month of July, a kind of combination of all the disasters took place, where in the month of July, you had a sporadic couple of these incidents of Western disturbances traveling over from the region of Mediterranean to the region of the Indian subcontinent. And when they came over to the Indian subcontinent, they collided with the Bay of Bengal branch of monsoon. And that is when the Bay of Bengal branch of monsoon and the portion of western disturbances, they collided over the region of Himachal Pradesh. Now you have a low pressure system which is coming over from the region of Mediterranean. You have low pressure system which is coming over from the region of Bay of Bengal. Both these low pressure systems, when they will combine, the amount of rainfall received will be very high, average, or low. It will always be very high, substantially high. So that is the reason why sudden cloudburst events and incidents, they have plagued the region of Himachal in the month of July. That is why the normally under normal circumstances you will observe more landslides and more cloudbursts in the in the region of Uttarakhand. But this year it is concentrated over Himachal because you have these western disturbances which are somehow still prevalent in the month of July, and that is because of climate change and global warming. You already are witnessing the impact of this, where the colder regions or higher latitude, they continue to generate the cold winds, and the warmer regions, the tropical regions, they are getting exceedingly hot. Okay, now these low pressure systems, let's suppose these low pressure systems, they travel over some area, over the region of northern portion of Rajasthan, portion of Delhi in the month of December. Now, when you have a very intense low pressure forming or getting traveled from that region, now can that create an event such as hailstorm? Can that create an event such as hailstorm? Yes or no? Yes? Perfect. So it is these low pressure systems which travel even during the months of November, December, January. Sometimes they lie over the region of Rajasthan, sometimes they lie over the region of Delhi, and that causes very intense vertical movement of the wind. That causes hailstorm events. That is why you receive sporadic hailstorms, or a kind of a seldom, very rare. That is once every 2 years or once every year, you will observe that you have the ice chunks which keep on falling along with heavy rain during these months in the areas, particularly in the region of Delhi, in the region of Rajasthan. And because it happens in winter, people mistake it to be snowfall. But that is not snowfall. That is your hailstorm. And that is created by the traveling low pressure. Okay. Now, the impact of this traveling low pressure, if you are ready to expand your horizon, I'll tell you furthermore. Now, these are prevalent even up till the month of April and sometimes even in the first week of May, generally. Now, it can also happen that this low pressure, it exists over this entire area. Now, this is what was experienced last year when you had a cyclone Tote, which developed over the region of Arabian Sea. Now, cyclone Tote, which developed here, it was supposed to hit the region of Maharashtra and Gujarat coastline, and further after that weaken thereafter, because after landfall the cyclone, the tropical cyclone particularly get weakened after hit after uh, basically experiencing landfall. But here what happened, that is when you had this low pressure of the cyclone, when it made landfall, it moved over to the region of Gujarat and it encountered this low pressure. Suddenly, the wind speed picked up. Devastation cost was immense. So, it is in these rare circumstances where you will find that the cyclone, even after making landfall, can get strengthened. And Cyclone Tote was strengthened by a residual low pressure created by Western disturbance. Okay, I hope this is the portion which is understood. Now, that is what is experienced in the condition or the season of the winter months. So, here, when we talk about the annual rainfall pattern in India, generally you will observe that majority of the part of the country receives orographic rainfall, or rainfall is dominated by the orographic condition. That is why western part of Western Ghats, northeastern mountain ranges, some parts at the Himalayan foothills, the southern face of the Himalayas, they will receive very excessive amount of rainfall, that is orographic. Otherwise, the leeward side will be drier. The portion parallel to the Aravalis, they will be very dry, right? Otherwise, in general, you will find the trend that the amount of rain reduces as you move from south to north, as you move from east to west. Now, you don't need to learn this particular map. even though sometimes when the rainfall pattern is asked in the mains examination, you need to draw this rough map, but just have it on the sheer basic concept that the western part of Western Ghats, very high rainfall because all the moist winds are directly hitting the coastline. The northeastern part, the Andaman Islands, very high amount of rainfall, and then rainfall pattern reduces as you move from south to north, as you move from east to west, because you are moving away from the source of the moisture. And also, it is the northwestern part of the country where you will experience the monsoons to reach the last and withdraw earliest. So that is the region on which the monsoons lie for the least amount of time. So that is the portion of Indian monsoon. Please do revise from the PPT itself, from the module itself, because when you directly approach the book, many of the times it will confuse you quite substantially. You won't be able to make sense of the concepts. But if you don't revise it immediately, trust me, you will forget this concept as well. This is the advantage that you have over your competition. Please don't let it go to waste. Okay, from here you will find many of the conceptual questions being asked in the examination. Please don't let loose of this advantage. Okay, try to understand it, revise it from the PPT itself. It is going to be much more than sufficient. Okay, now let us take a look at this question then. So, which of the following correctly describe the phenomena of western disturbance? So these are the aggravated monsoon winds blowing from west to east. They originate over the Mediterranean Sea and are carried to India by winds. Their effect can be felt mostly during the months of July to September. They can bring rains only over the hill tracts of Himachal Pradesh. Good. Correct. I expect almost all of you to give the correct answer in this. No, Usha, that is incorrect. Good. A substantial majority of you have given the correct answer. So they originate over the Mediterranean Sea and are carried to India by winds. These are not monsoon winds. So first is incorrect. Their effect can be felt mostly during the months of July to September. No, it is felt during the winter months, right? During the winter months is when you experience this. Then they can bring rains only over the hilly tracts of Himachal Pradesh. Incorrect. They can bring rainfall in Punjab, Haryana, Uttar Pradesh, northern Rajasthan, Delhi, even as far east as northern portion of Bihar, northern portion of West Bengal, and even in the area of Assam. Okay, right. Now, then after that, consider the following statements about the phenomena of El Nino and its effect on Indian monsoon. It occurs, now this is a question, have we discussed that? Okay, nonetheless. It occurs in the region of South Pacific and hence has no impact on Indian monsoon. It leads to increased rainfall over Indian subcontinent during the monsoon season. Its impact can be neutralized by Indian Ocean dipole and Madden-Julian oscillations. Correct. Garvit. Sayyad. Correct. Smriti, Sumo, Manikandan, Tarun, Manas, Anushka, Ushashri, this time you are correct. Satyapal, correct. Tarun, yes, correct. No, Sargun, that is incorrect. Muskan, correct. Days of elimination are not there. No. Shiva, correct. So again, majority of you have given the correct answer. So it occurs in the region of South Pacific and hence has no impact over the Indian monsoon. Incorrect. It leads to increased rainfall over the Indian subcontinent during the monsoon season. Incorrect. Its impact can be neutralized by IOD and MJO. This is correct. So the answer will be C, that is 3 only. With reference to the retreating monsoon, consider the following statements. The Coromandel coast receives heavy rainfall as a result of this. It generally spans over a long duration from September to November. The movement of winds is from southeast to northwest. Which of them is going to be correct? Gulam, thank you for that. But then that is why I suggested please don't confuse yourself with GC Leong. GC Leong is going to help you in the next portion that we are covering. That's it, the theoretical portion. Otherwise, GC Leong is not much of a help. All of you are correct in this, except few of you. Tarun, Pratyusha, you're incorrect. Gayatri, you are also incorrect. So correct. Most of you have given the correct answer. That is A, 1 and 2 only. Coromandel Coast receives heavy rainfall. It spans over a long duration from September to November. Movement of winds is not from southeast to northwest. It is from northeast to southwest. Okay. So that is why it is incorrect. Okay, so now let's take a break, and after the break we'll come back and we'll talk about the global climatic classification. I'll tell you how to cover this area and then we will proceed. Okay, third is wrong because the direction of the wind movement is incorrect. Southeast to northwest is what? This is your southeast to northwest. That is why it is wrong. Yes, Pratyusha, I'm doing fine, thank you. And now we'll come to climate classification. Before that, we take a break. We'll be back around 7 and then we will continue. A confirmation about the audio, please. If the audio is clear and available, kindly confirm the same. Thank you. I'm doing fine now. Thank you. I'm doing better. So, Subramanya, what is your question, my dear friend? Basu, when does ITCZ reach its maximum northward shift in northern subcontinent? Generally during the month of later part of June and also July. Which topic we should do from India, Majid Hussain book? Generally, no topic for general studies requires Majid Hussain. So that is where I would suggest to you that generally people refer the portion of Indian geography from Majid Hussain. But there, I would suggest to you that if you want to score good marks, refer to the basic of NCRTs along with the PPT and keep on updating yourself with as much current affairs as possible. That will be more than sufficient. GC Leong is something I would not recommend. GC Leong is there only for physical geography, and in that, only this particular chapter that you are going to read, that is the only chapter which is mentioned in greater detail, in greater depth. Other than that, GC Leong is not something that is advisable. Okay. Why ITCZ is not straight? Because ITCZ represents a thermal low pressure, and that thermal low pressure will so different areas, they will always represent different temperatures. If the region around the particular portion would represent in a straight line the same temperature, then ITCZ would have been a straight line, but it is not the case. Okay. Nothing, sir. You don't tell my name till long time, therefore I confuse that classes are moving very forwardly. So don't worry, Subramania, we have a separate doubt clearing session on 25th, I guess, if I'm not wrong. So 25th, we'll have a separate doubt clearing session itself, where we won't be talking about any of the other concepts. We'll just be clearing doubts. So you can bring the doubts at that point of time. Shiva, this geography sufficient to complete the UPSC preparation along with the portion of additional reading materials and current affairs? Yes. And is NCRT enough? Yes, Rohit. Why mascarene high is not created on the equator? Why will the mascarene high be created around equator? There is no reason for the mascarene high to be created at the region of equator, is there? So mascarene high is basically the southern subtropical high pressure belt. It is a dynamic high pressure. So that is something which will never come to the region of equator. It might move slightly to the north, it might move slightly to the south, but it will never come to the region of equator. Okay, right? During the retreating monsoon, how trade winds cross Himalayas and come through India, basically towards Chennai. So it is not. So that is where I told you that during the time of the retreat, that is where the Potwar plateau that starts generating the high pressure winds. So the winds need not cross over to the region of Himalayas. That is where they are driven basically from the portion of the Indian mainland itself. Okay. Now, uh, no Lakshya, even the PPT plus ARM would be sufficient. Okay. So now we come to the portion of climatic classification. Some lecture notes I could not complete, so where I start. So you start from the very basics, from the portion that you are feeling any kind of doubt. That is where you start. uh, it would be clear to new students if you start it from the NCRT chapter wise. So when we are covering any particular topic, we are covering from the very basics. Many of you have joined climatology in the midst of it, right? So if you refer to the students who have been attending from the initial portion, there is a substantial from very basic we have started covering it. And that is how we elevate the concepts over a period of time. Okay, but I'm not going to cover it that this is chapter 1 of NCRT, this is chapter 3 of NCRT, this is chapter 5 of NCRT, because to be very honest, these lectures, they are not driven by the NCRT notes. If that would have been the case, that I would help you to study NCRT, then you will never be able to elevate your level of discussion, your level of concept. That is why I refer to the NCRT, not because that you will find all these portion in the NCRT. I refer you to the NCRT that you have something to fall back upon. Okay. So please don't think about it that everything that you study here, many of the portions that you find in this particular lecture, they are not given in the NCRT at all. For example, in NCRT, you will never find the explanation of how is it that Enzo cycles, they end up impacting the Indian monsoon by the transferring of the ocean current. You will not find any mention of Indian Ocean dipole. You will not find any mention of MJO circulation. You will not find the mention in detail about the temperate and the tropical cyclone. So there are many portions which have been covered in the class which are not even there in NCRT. So it would be a kind of a waste of your time if the book that you have, if I teach the same thing and then you go back, you repeat the same thing in the book. So that is something which works up till your class 10th level. That, okay, whatever the teacher has taught, even if I don't pay attention, I have the book to rely upon. So that is something which works up till there. I'm sure you are here in these sessions because you want to elevate your basic level of concepts. So those level of concept elevation, that is something which will be done. Okay, right? And while revising through class lecture video again, how much time as seminar goes in videos only? So it depends upon how much you have extracted from the session. So if you revise it immediately, you will be able to do it within a couple of hours if you have revised. If you leave it after or if you leave it for revision after a long period of time, then you will take substantial amount of time to carry out the process of revision. Okay, and is geography is part of science in old times. So many portions of geography, they are driven by the scientific concepts and phenomena, but we have not been talking about any of those scientific phenomena in detail. We have only covered it from the basics, so that even I understand majority of us are from arts background, so that arts or humanities background, so that it is easier to consume. Shall just start with the portion of editorial. 11th and 12th NCRT is more than sufficient. No, this is the last module of climatology, Weber. Okay. So now, Roshan, that is a good optional subject to select. Okay. So now we come to the portion of the final module of climatology. After that, we will initiate the discussion for the portion of oceanography. And this portion of climatology will require you to implement the ideas that you have gained from the aspect of the pressure zones, the permanent wind system, also the development of cyclones that we have seen. Here, we will study about the world. This comes very much under the portion of world geography, where we will be talking about what are the climatic conditions experienced across the world. So this is where we will have the classification of climate, okay, which is experienced across the world. So here, when we talk about this, this is going to be relevant only for your prelims. In general studies, UPSC is not going to ask you about this in the mains examination. So in the prelims, what is it that you expect? So you expect the questions which will ask you about the basic phenomena of climate types. So there are four climate types which UPSC keeps on repeating. So I should also be telling you about those basic climate types. So you have the climate types such as Mediterranean. We will come to the Deccan Trap in Indian geography, Shivaji, if that is fine with you. Then British, Equatorial, Savannah, okay. So these are also, sometimes you can have the China type, So these are the basic climate types for which you should know the feature. That is it. Okay, that is all that you need to be aware of, well versed with. You should be aware of all the various different climate types across the globe, but I understand that you will find this portion very theoretical. That is why in this portion, I have ensured that the PPT is very text heavy. You had also, many of you had requested to include more text in the PPT. So this is very text heavy PPT. And because it is mostly theoretical in concept, so rely on the PPT and additional reading materials itself. That will be more than sufficient here. Now, let me tell you here, when we talk about the portions, so here, we will study about Köppen's classification. Köppen's classification of climate. So this Köppen's classification of climate codes for various different climate types. Are not asked in the prelims or mains. You just need to understand the basic feature. Stress upon the basic feature of climate. Okay, so that is where we will be concentrating upon. We will study about the various codes. So here we will be talking about the Köppen's classification of climate. Now, Köppen basically provided the classification or the distinction of the global climate types more than 100 years back, almost around 1900. Now that Köppen classification also over a period of time has gone multiple different undergone multiple different modifications to adapt to the real climatic conditions which are experienced in various different parts. So you have the classification as Köppen, Geiger, Pole, and these kind of classifications and modifications have happened. You have the climatic classification which have been brought by Thorndike and Trevartha. So they have also brought in their climatic classifications, but they are not relevant for your general studies at all. These are asked in the optional area in the portion of the mains. But then for your GS mains, this is a portion that UPSC has been avoiding in GS for a very long period of time. So please don't overstress yourself that I need to rectify or rote learn the entire portion of this climatic classification for GS. Okay, mains, it is for your prelims where questions are oftentimes repeated from these set areas themselves. Okay, so let us embark upon the discussion of this. Let us understand what this Köppen classification is. And here we shall be moving slightly with a greater amount of pace in this particular module only. Not from here now on, only for this particular module, we shall speed up a little bit because this portion is largely theoretical, which you will understand after a few slides. You will understand how theoretical it is. And it is the PPT which has contained all the text that will be required for your revision purposes. Here you need to understand how is it that global climate is influenced, which areas will receive rainfall, which areas will receive dry conditions due to shifting of pressure belts, due to the generation of onshore offshore wind pattern. So that is what ends up defining the climate experienced in different parts of the world. Now earlier, now the planet was basically divided into different climate zones thousands of years back, and you had the region around the tropics being regarded as a torrid zone, the region in the mid latitude. Now, why it was regarded as a torrid zone? So, basically, the earliest classification which used to exist, the earliest form of classification which was followed by the world for a long period of time. So, there you had the existence of a very cold frigid zone or frozen area, the existence of a very hot region, that is the torrid zone. Now, this is a region which the Greeks thought nobody could have lived in that area. Nobody can survive in that area because of very high temperature. So they thought that the temperature and the conditions are so very oppressive, it is not fit for human habitation. That is why they classified it as a torrid zone. Then further higher up in the higher latitudes, they named it as a temperate zone. Temperate zone. And further higher up in the higher latitude, you had the frigid zone, the polar region, which were consistently frozen. You had the frigid zone. Okay, so this was the classification in general. Now, here, for a long period of time, this form of classification was observed, was believed. But obviously, as people got to know about the world over the hundreds of years, they got to know that even within the various different tropical areas, you experience different climatic conditions. Even in temperate areas, you have variation in rainfall, you have the desert areas, cold desert, hot deserts, all of them existed. Now, by the 1800s, you had a lot of research which was already carried out by the paleontologists, by the botanists. So, you had one of the very detailed compilation of the natural plant types found in areas across the world by a French botanist and biologist with the name Candolle. Now, Candolle, in 1870, he compiled a very detailed book explaining the various plant types to be found across the world. Now, when you talk about the plants, in order to grow, now different areas have different types of plants. The kind of plants that you find in Tamil Nadu, that is not the kind of plant you will find in coastal Karnataka. The kind of plant that you find in coastal Karnataka, you will not find in Uttar Pradesh. The kind of plant you find in Uttar Pradesh, you will not find in the region of Ladakh. You will not find in the region of Punjab. So, the plants, they are dependent on what? They are basically dependent on temperature, amount of rainfall. That is what they are dependent upon. So that is where you had Vladimir Koppen. Koppen basically utilized that kind of classification of the distribution of plants, and he used that to classify the climates because he understood that, let's suppose, in the region of Java and Sumatra you have a particular plant type, so there must be a particular climate which would support that plant type. There must be a particular climate somewhere which would support xerophytes or desert plant. So based upon the classification of the vegetation, because vegetation, he was very sure about it, that vegetation dependent upon, when we talk about vegetation, it depends upon temperature and also rainfall. Now, based upon this, he classified the global climate. And in order to classify the global climate, he used the alphabets, the capital alphabets, the small alphabets, etc. He used this to classify the climate, classify the amount of temperature, classify the amount of rainfall experienced, the distribution of rainfall which is experienced. So the zonation was done across the planet. So he used the letters A to E, C, D, and E. Now, A would represent equatorial kind of climate, type of climate. B would represent the desert areas, deserts and semi-arid. climate. C would represent the temperate regions, particularly the coastal temperate areas, which would experience moderate temperature. That the summer is not very hot, winter is not very cold either. So C would experience moderate climate type. Then D is what he used to designate the regions of slightly higher latitude, such as northern Canada, Siberia, which would have very cold winters. They are not exactly polar, but very cold winters. So that is where regions such as Siberia, Canada, in these areas. So very cold winters. And then you had E type, which is significantly what is referred to as the polar climate. Okay. Kirti, humble gratitude from our side for such kind words. So, this is basically the kind of polar climate. So, this was the basic broader classification which was done. But then he was also sure about the fact, and he also observed the fact that despite being in equatorial region, despite being in, let's suppose, the subtropics, etc., sometimes when you encounter very high altitude, the temperature experience is less. What we experience in the case of the hill stations, what we experience in the region around, let's suppose, the area around Tibet, etc. So these are the areas where the temperature is different, the rainfall conditions are different. Why? Owing to the height, owing to the altitude. So that is where, due to the height, you have the difference in temperature. So that is where he designated the letter H. H would represent highland type of climate. Okay, that would represent what is referred to as the highland type of climate, where the temperature would be different only owing to the altitude factor. H is also there, H is also there. Okay. So, Maria, now I hope you have some amount of satisfaction. Consistently, you have been typing H is also there, H is also there. Now that you have seen H, I hope some amount of satisfaction prevails. Please understand, I won't omit any particular thing that you have studied in the book or that you have come across online. Okay? So please have that amount of faith that it is not going to be the case that H, and that too a simple concept like Highland, I will not be ignoring that. Have that much level of trust. If not trust, have that much level of confidence. Okay? So this is the area which we talk about different climatic conditions owing to height. Conditions owing to altitude. That is because of altitude factor. Because in the same latitude, in the similar latitude, Ooty will experience a very different temperature than maybe if you consider Chennai, right? Agra and Darjeeling, we have taken a case of it, that despite being on the similar latitude, Agra is much warmer as compared to Darjeeling. How do you classify those areas then? So for the ease of classification, that is why this kind of categorization was done, a separate H was put into. Now, this is the written portion of it, the alphabetics that you will see. That A type. A type is what? You have humid tropical climate, right? Humid means moisture is very high. So tropical, because tropics, they experience a slightly higher average temperature. That is why tropical. Warm and moist conditions throughout the year, and mean temperature is always above 18 degrees Celsius. the mean temperature, the mean average temperature is always above 18 degrees Celsius. That is the A type of climate. Okay. Then B type. B type is where you will have dry climate. Right. Now, B type, I will tell you also how to find a pattern in this, that how you will find the, because you will be flooded with so many alphabets within the next 10 minutes that your mind will get clogged very easily. So, I will tell you the pattern which will help you to recall this. But again, I would repeat, learning these codes is not very important. UPSC is not going to ask you the codes for the prelims examination, let alone for the mains examination. So here the B type is the dry climate where there is a moisture deficiency, right? So you have moisture deficiency. That is desert and semi-arid. Semi-arid. Semi-arid means what? Arid means a desert. Semi-arid means what? Periodic rainfall you will receive. Maybe once every 2 to 3 months or once every month. That periodic rainfall. So that will be enough to support some grasses, but not enough to support the trees. So here, this is generally observed in the subtropical high pressures. Generally, subtropical high pressure areas. Then we have the C type, which is where you have the moderate climate. That is, the winters are not going to be very cold, summers are neither going to be very hot either. So you have mild winters, average temperature of the coldest and the warmest months being between 8 to 18 degrees Celsius and around 22 degrees Celsius. So that is where you have moderate. So this is the temperate climate, generally found across the coastal areas in the mid latitudes. So generally along coastal areas in mid latitude. Okay. Then you have the D type. D type is where the temperature goes very low during the winter. It can be around -3, -5, -10. And in summer months, at max, it will go to around 10, 15 degrees Celsius, not more than that. So, northern Canada, Siberia, these are basically the D type. These are not exactly polar, but then these are found in higher latitudes where the temperature goes very low during the summer months. Then you have the E type. E type is the polar climate characterized by the summerless season. That means you don't have the occurrence of summer season at all. Even in the summer season, in majority of the cases, the temperature remains below freezing point. So that is the E type of climate. Okay. So here, if you want to recall this, you can form your own mnemonic. Yes, you can form your own mnemonic as I am seeing Bhavi is developing that, that B for barren, C for classy, etc. So you can develop your own mnemonic, but then overall understand the basic pattern here, the basic trend that you will observe, that closer to the equator, you will find the A type, right? Closest to the equator, around equator, you'll find the A type. There are variations at that as well. Then as you move slightly away from equator, you will find the B type. B type is present here. This is your B type. Then across the coastlines, you will find the C type. Then furthermore, closer to the poles, you will find the D type. And immediately at the regions of the pole, you will find the E type. So A type begins at the region of equator, slightly and steadily as you are moving away from the region of equator. That is when you will go to B, C, D, and eventually E type. Okay. Now, across the entirety of the region of equator, obviously the amount of rainfall will change, the pattern of rainfall will change. In certain areas, you will experience rainfall on a daily basis, in certain areas, not the case. So, there is a classification even based upon the amount of rainfall received. If you have a rainfall which is received throughout the year, then you have the letter F which is attached. For example, AF, right? You have the letter F which is attached after that. Means full throughout the year. You have full rainfall. You can use that as a shortcut. So, no dry season means rainfall is received throughout the year. Rains throughout the year. Okay. When then you have the M, that is AM, right? M is attached sometimes. That represents monsoon climate. Where you have in monsoon climate, what is the phenomena? Substantial chunk of rainfall is received only during the months of the monsoon season. Around 70 to 80% of the annual rainfall is received after the dry conditions, after the prolonged summer conditions. That is when you receive substantial chunk of rainfall. So here only during the monsoon months, range during monsoon months. Then you have W, that is winter is dry, means rains are received only during summer. Then you have S, represents summer is dry and rains only during winter. Furthermore, you have a classification into A, B, C, and D, small a, B, and C, and D, and that is attached to represent the severity of temperature. For example, you will find CFA, you will find CFB, and so on. So that is to represent the severity of temperature. You have another kind of classification which is done in the case of the desert climate. We will make ourselves familiar to that when we come to B type. Okay. So here, one by one, what we'll do is we'll make ourselves familiar with the different type of climate, the features, the patterns of it, and also I will show you the climate curve, the precipitation temperature curve for different areas as an example to indicate to you that what is the temperature that is experienced, what is the climate that is experienced. Okay. So for example, when we talk about the group A or the tropical humid climate, now, these are the regions around the area of equator within the tropics themselves. So, these will receive rainfall due to the convectional rainfall anyways received in the equator, and also they will receive rainfall due to the shift of the ITCZ. So that shift of ITCZ will, in a way, bring about a difference in the wind movement. Wind movement can get onshore or offshore, as we have seen in the case of India, that how the shift of the ITCZ can create a wind movement to be onshore and then again offshore during the months of the winter. So that is how, with the shift of the ITCZ and the equatorial condition, you experience this A type of climate where the average annual temperature is going to be very high. The range in temperature is going to be less. What do we mean by that? That basically means that difference in temperature between the summer and winter is not going to be very significant. You will have a consistent temperature. Why? Because the moisture availability is going to be very, very high. So you have a consistent amount of temperature which is experienced. Okay. So here, tropical humid climates exist between Tropic of Cancer and the Tropic of Capricorn. That is where the tropical humid climates will exist. Okay. So that is in the tropical region. Now, the sun, which is overhead throughout the year, and the pressure of the ITCZ makes the climate hot and humid, brings substantial rainfall, causes substantial amount of rains. Okay. Annual range of temperature is very low. Range of temperature is low. means the variation in temperature between the summer and the winter months, that is very low. That means temperature is almost consistent throughout the year. Okay, so temperature is almost consistent throughout the year, is consistent throughout the year due to high amount of moisture presence. High moisture presence. Okay, and then the annual amount of rainfall received, that is going to be substantially and significantly higher. Then the tropical climates, the A type, is further subdivided based on the rainfall pattern. That when is it that rainfall received in which part, you have more rainfall, less rainfall, etc. So this is basically the classification on the rainfall type. You have the tropical wet climate where AF is used, means it will rain throughout the year consistently. Tropical monsoon climate, much amount of rainfall will be received only during the monsoon season. And then tropical wet and dry climate, where you have the savanna climate which is experienced. So here, this is the aspect or the climate curve or the climate graph of the AF type, where you have rainfall throughout the year. So observe certain areas. This is for equators in Peru, which is equatorial in nature. Observe that rainfall is received through the year, be it January, February, March, April, May, June, July, August, September, October, November, December. Every month, you receive some amount of rainfall, and observe the temperature. So temperature is consistent, rainfall is received throughout the year. Temperature is consistently hovering between 25 to, let's say, 27, 28 degrees Celsius. That is the consistent temperature which is present. So that is where the temperature is consistent, amount of rainfall received is very high. Now, here, constant or consistent temperature reigns through the year. Throughout the year. Okay. So here basically observe the amount of rainfall received every month. So you will observe almost every month you have close to around 250 to 300 millimeters of rainfall which is received, right? Every month almost. So to almost 200, 250, 300 mm of rainfall you will receive every year. Now, which kind of rainfall is received here? What is the which kind of rainfall do you think will be observed here? We have talked about the classification of rainfall. What kind of rainfall? Very good. You will receive here convectional rains. Convectional rainfall. Okay. So accompanied by thunderstorm, lightning, cumulonimbus clouds, all those facts that we have studied earlier. Now here, you will find that because the rainfall is so abundant, you will find the predominance and the presence of equatorial forests. That is the rainforest. The tropical rainforest is something that you will observe where the trees grow very, very large, very, very tall because of abundance of moisture. They are going to compete for the availability of sunlight. We will discuss in detail, or you will discuss in detail about all the plant types and types, etc., in these areas in the portion of environment and ecology. Okay. Now, AF, it is a tropical wet climate. Precipitation occurs year round. Variation in temperature is less than 3 degrees Celsius. Humidity is extremely high, and the surface temperature results in formation of cumulus and cumulonimbus cloud in the early afternoon time on a daily basis. This results in a high daily amount of rainfall. Tropical evergreen forest with dense canopy cover. What is canopy cover? So if you consider this as the forest, let's suppose, So this is the portion that you would describe as the canopy cover. This is your canopy of a tree. Okay, so you have almost equal length of day and night, and generally found at the region of equator. So Peru, Amazon basin in the region of Brazil and other parts of South America, Congo River basin in the region of Africa, the islands around the region of equator, that is Philippines, Indonesia, Sumatra, in those areas also you will receive this equatorial climate. Okay, so here these are the aerial spread that you will find. So this is around the region of equator, around the region of equator. So you will receive very heavy amount of rainfall. So this is your AF type. Then after that, you come across what is AM type. That is the monsoon climate. Now, in the case of the monsoon climate, now by the way, AF type will also be experienced in the tropical island areas. Because tropical islands, remember we had discussed during the time of the convectional rain itself, that tropical islands will also experience significant amount of evaporation, condensation, and occurrence of convectional rainfall. So island regions, they also experience the daily evening occurrence of rainfall. Then we have the AM type, that is the tropical monsoon climate. So, tropical monsoon climate basically here you have the maximum amount of rainfall received during the monsoon season, during the monsoon months. So, annual rainfall is similar to that of AF, but precipitation usually occurs within the 7 to 9 of the warmest months of the year. So, that is where the amount of rainfall is similar, but it is concentrated during the monsoon season. Okay. During the rest of the year, there is lesser precipitation. Winter is comparatively drier, comparatively. Found over the Indian subcontinent, northeastern part of South America, northern Australia, heavy rains occurs mostly in summer due to the shifting of the ITCZ. Here you will find broad-leaved evergreen forest with deciduous trees and plants. Deciduous trees we will study later on in portion of biogeography. Deciduous trees are those kinds of trees which shed their leaves during the dry season, and the entire forest will give you the appearance of a kind of a dried area because all the trees will be shedding their leaves. Why? Because the leaves, through the pores that they have, they consistently keep on emitting moisture into the atmosphere. They continuously keep on releasing moisture into the atmosphere by the process of evapotranspiration. Okay, now this is the representation of AM type, that is the tropical monsoon climate overall. So tropical monsoon climate here, observe this. So when we talk about this here, even though the temperature is largely consistent, you will observe that there is a peak in rainfall received during the months of May up till around October. That is it, during the monsoon months. But what is the amount of rainfall received? You have almost 1000 mm to 1100 millimeter of rainfall received in 1 month, isn't it? 1000 to 1100 millimeter received in 1 month. In the case of AF, what did we have? We had around 250 received every month. So closer to 4 months of rainfall received in AF is received in monsoonal climate only in 1 month. So you have almost equal amount of rainfall as compared to AF or equatorial, but concentrated in few months itself. So almost the equivalent amount of rainfall, almost equivalent amount of rainfall as compared to AM, AF, but concentrated in one This is very difficult to remember. This is impossible to remember, let me tell you. If you try to remember all this, it will be impossible. Unless and until you have devoted, you are very good at learning stuffs, which almost all of us are not good at it. Or let's suppose if you have revised this 50 times, 100 times, but then when will you revise other subjects? That is why I'm telling you, please don't harp upon the quotes. Here, understand what is the equatorial climate, rainfall every day. What is the monsoonal climate? Much amount of rainfall restricted in a few months after the summer heating. That is it. Is the mains PYQ of color coded cyclone warnings related to this topic? No, it was actually related to the portion of tropical cyclones. We had discussed about this in the portion of the cyclone classification as well, but it is something which was very much relevant in the current affairs. And due to the occurrence of multiple cyclones, that is why you had that question appearing from. But we had discussed about this, if you recall, that you have the low depression, you have the intense cyclone, very strong cyclone, then you have super cyclone, so red, orange, yellow, green. That is the classification. Okay, so this is the AM type. So AM type, generally you will observe wherever you have the monsoonal climate, slightly away from equator as compared to AF. AF will be exactly at equator. Slightly away, still in the tropics, you will experience the AM type of climatic conditions. Then we come across what is referred to as the AW, or the tropical wet and dry climate. Now, this tropical wet and dry climate, this is what is also referred to as savanna. So, this is what is referred to as the savanna. And here you observe just the image first of all. Then we will go to the written portion. Just the image, if you observe, you will observe that the trees are very less, isn't it? Few trees. Generally, grasses, isn't it? So, by this image itself, what can we conclude about the moisture, amount of moisture, or the amount of rainfall? Do you think this region would be experiencing high amount of rainfall or less amount of rainfall? Less amount of rainfall. Do you think the temperature would be high or the temperature would be low? What do you think? Temperature would be high, isn't it? So it is in tropics, right? Then it is comparatively drier. Now, we have talked about it earlier in the basic concepts. So, when you have a dry region, when you have a moist area, now the loss of heat will be higher in the case of dry region or in the case of the moist area. Loss of heat will be higher in the case of the dry or the moist. Beautiful. Always in the case of always in the case of dry, because moist air will retain heat. So, in the if we talk about the nighttime temperature or the winter temperature, that will be colder in the dry area or in the moist area. The nighttime temperature and the winter temperature will be colder in dry area or moist area. Always dry area, because that is where you have loss of heat because of dry lapse rate, which will come into the picture, isn't it? So that is the basic phenomena here. Here the amount of rainfall is less. You have the rainfall in very few months, right? So here you will receive rainfall during the summer season for certain months. Winter is mostly going to be very, very dry. That is why here you will find that because it remains dry for a very long time, you have the conditions of very dried grasses. And then before the onset of rainfall, as the clouds they start to build up, that is where the thunder, lightning strikes the ground, and easily wildfires are observed, where the dried grasses they get burnt. It is in these areas where you will observe large scale animal migrations, where elephants, zebras, etc., they will move for very large number of kilometers to get access to some amount of water. Again, as the rains come, suddenly everything will become very, very green. Serengeti region in Tanzania, one of the examples of this condition. So observe here that rainfall is received during the summer season. Otherwise, it is generally drier. So basically, these are your areas. So here you have the creation of tropical grasslands. Tropical grasslands are experienced. So here you have Campos as the grassland in the region of Brazil. You have Llanos in the region of Venezuela. These are your grasslands. Okay. Now, please don't get confused by this image. This is for Brazil. Brazil lies, and this portion lies in the southern hemisphere. So the winter and summer will be different for Brazil as compared to India. So here, tropical wet and dry climate. So wet season is very short and dry season is longer, with the drought being very, very significantly severe. So here, the temperature is high throughout the year, and the diurnal ranges of temperature, that is the daily range of temperature, is the highest during the dry season. That means during the dry season, the daytime will be very hot, nighttime will be substantially cold. So what diurnal range of temperature means is daytime temperature is very high and nighttime temperature is very low. Okay? Because of dry lapse rate. Now, tall to continuous grasslands with scattered deciduous trees, which will also shed their leaves during the dry season. So, northern and some northwestern part and some part of eastern India, interior portions of Burma, Llanos of Venezuela, Campos of Brazil, western portion of Central Africa. That is where you will experience the savanna. So, this is your savanna. So, this is where you will experience drier climate. So it is a dry climate which restricts the growth of various different trees. Then we come to group B, which is the desertified areas. So here, most of the deserts that you find are created because of two major reasons. One of the reason is there are certain other reasons as well. When we study about ocean currents, we will expose ourselves to those concepts as well. But as of now, the prime two reasons for the creation of the desertified area. Now, desertified area means what? Desert does not mean you need to have these sand dunes and the flowing sands that you see in the movies where the actors they are going there only to have a song and celebrate over that. No, desert means a general lack of precipitation. Desert means there is a moisture deficiency. That is, the amount of moisture received during rainfall or condensation is much less than the amount of moisture which is lost due to evaporation. So there is a consistent moisture deficiency, and hence plants are not supported. So that is the desert area. Now these desert areas, they can either be created in the region of the subtropical high pressure, where in the subtropics you have sinking air. So despite the high temperature, you have no rainfall, right? So either due to subtropical high pressure, okay, or due to the continentality of an area, where a region is present in the hinterlands and in the leeward or the rain shadow zones of areas which anyways receive less rainfall. For example, Central Asia, around the region of Mongolia, many areas of Iran. So that is where, due to continentality, tality. That is, and being in the leeward side of mountains. Okay. Now, that is your B type. Now, B type, type, deserts can be cold, deserts can be hot. Now, if you have a desert in a higher latitude, it will be a cold desert. Many areas in Ladakh, they are cold desert. Because they are deserts, means they are unable to support plants consistently. That is why they are deserts, because of moisture deficiency. But if the average annual temperature is less than 18 degrees Celsius, you can classify it as a cold desert. If the average annual temperature is higher than 18 degrees Celsius, then you classify it as a kind of a hot desert. Okay. So accordingly, you have, for example, Gobi Desert in Mongolia. That is something which will be classified under a cold desert. Right. So that is how you have the general classification. So Group B climates. These dry climates are characterized by very low rainfall that is not adequate for the growth of plants, large diurnal temperature range. That means the day temperature is going to be very high, night temperature is going to be very, very low. Highest daytime temperature, evaporation and transpiration play a greater role in shaping the vegetative state than the temperature in itself. So these are more prone to play a substantial part. Okay. Then after this, here, these are your desertified or the B type of climate. So for example, when you consider the deserts in Central Asia, now these are not in the subtropical high pressure zone, but these are so far away from the region of the moisture that you don't have occurrence of rainfall. Some sporadic rainfall might occur due to development of front, and frontal rainfall might be observed in this area. Otherwise, it will be a desert. So in these areas, semi-arid conditions, that some grasses, etc., might be observed. These areas, the subtropical high pressure belt. So in the same latitude, I had asked you that observe the same latitude at which we have the northern part of the country. You will find only deserts, but northern part of India is not a desert. What do you think is the factor that the northern part of India is not a desert, but all these are? Very good. Because of the Himalayas. The Himalayas, they obstruct the moist winds. They don't allow the moist winds to flow northwards. So that is why if the Himalayas had been smaller in height, then you would have the northern portion of India also designated as a desertified region. So here you have further classification which is carried out, and that is the classification into, so B type is further classified into BW and BS. BW represents a desert, BS represents semi-arid. Means very little amount of rainfall, and that too by frontal occurrence, or the frontal rainfall is what you will experience sometimes. Otherwise, semi-arid conditions. And these are your deserts, complete and significant deserts which are prevalent. Now even there you can have cold desert and hot desert. So you have BW, which is further classified into BWH and BWK. That is your hot desert, and this is your cold desert, where you will find average annual temperature is higher than 18 degrees Celsius. Average annual temperature is lower than. Okay, that is the classification. Now, here, so BW type, that represents around 12% of the Earth's total area. That is the dry desert. You have very unique kind of plants which are very seasonal in nature, but more or less they won't have leaves. And why is it that they don't have leaves? Because through leaves, the plants lose moisture. And here, the plants need to retain moisture. That is why the green pigmentation or the chlorophyll will be found to be present in the region of the stem itself. So, stem is where you will have the food also, which is stored. So, that is where you will have fleshy stems. And the thorns are present on the stem to obviously keep the predators at bay so that the food and water can be stored there. So the letters H and K are used as suffixes after BW to represent whether it is a hot desert or whether it is a cold desert. Generally, cold deserts, they will lie at higher latitude as compared to hot desert. Okay. So here, this is the classification or a characteristic of the BWH climate. So some of the driest places across the planet will be found here. Very low limit relative humidity, large diurnal temperature range. So the temperature peaks during the summer, but the amount of precipitation is almost negligible. Then you have the BS type, which is the semi-arid type, which represents 14%. So they receive more rainfall than the BW counterparts because of mid-latitude cyclone or the frontal cyclone. This is basically due to frontal formation. Frontal rainfall. Okay, so that is the classification in general. Here, by the way, if you take a look at the map here, you will find BWH and BWK. So BWH, these areas, and the BWK, these areas. Even Ladakh will come under BWK. This is very theoretical. I agree. This is one of the most theoretical portions that you will come and encounter in geography. BWK or BSK? Okay, I would like to ask, which is the book that you are opening right now? Which is the book that you are referring right now, Maria, where you are getting this very frequent fear of missing out or FOMO feeling? Which is that book that you are opening? Whichever book you are referring to, please understand we are going to cover the basic portion in the PPT, and the basic portion that we are covering here, that is more than sufficient for your examination. Okay, so I hope it gives you some amount of relief, the consistent fact checking which is going on. So do one thing, as of now, try to close the book. After the class, after the session is over, then you can open up the book. You can explore as much as possible. As of now, just close the book for a few moments. Please pay attention on what is being talked about. Okay? You will understand. Okay? I hope I'm making myself clear here. Right. Now, this is your BSH. BSH is the hot semi-arid area where you will find, for example, the presence in the region around Australia, again in southern hemisphere. So that is where some amount of rainfall would be received during the summer season. Otherwise, not significant amount of rainfall to be observed. The temperature range is very, very high. Then you have BWK and BSK. These are your mid-latitude deserts and the steppe. Steppe is where you have in the temperate region, you have the presence of grasslands in that region. So steppe represents the grasslands which are found in the region of Central Asia. So these represent grassland in Central Asia. Okay. So here, what is the climate type that you generally observe is that it is very dry. B type means very dry. W means absolute desert, like the Gobi Desert. K means low temperature, colder conditions. So BWK Even Ladakh will represent a kind of a BWK, right? So they are dry because of extreme continentality and the effect of high elevations, that is high altitude. That is where you have low temperature. Now, continentality means being at the center of a continent limits the amount of moisture supplied from the various oceanic sources, and without this moisture, precipitation does not occur. Sometimes some amount of rainfall will be received, however, in BSK, again due to creation of a front, or what we have studied earlier as the frontal rainfall. So that is where sometimes some amount of rainfall will be observed. Okay. So presence of mountains upwind of these climates can further reduce the moisture availability because of rain shadow effect. That is the leeward side. Okay. Then major expanses of mid-latitude deserts can be found to the east of the Caspian Sea, north of the Himalayas, in western portion of United States, such as the Mojave Desert, in the region of Utah that you have in US, and the east of the Andes, and also around the region of Atacama Desert. Mid-latitude deserts have a greater range of both daily and annual temperature as compared to the subtropical counterparts, because here the nighttime temperature goes very, very low as compared to the subtropical. Okay, mid-latitude steppe receives some rainfall of rain due to front formation, enough to support grasses for few months. So what will be the prime occupation in these areas? Can we say that agriculture will be the prime occupation? No. Here you will find animal rearing, animal husbandry, and pastoralism to be the prime occupation which is observed. Okay, so most of the people here will be nomadic in nature, they will be pastoralists. So basically, they would be depending upon the grazing of the animals upon these particular grasses. Okay, so this is the kind of precipitation pattern. Then we come to group C, that is the mid latitude climate. This is where you observe moderate kind of climatic condition without any extremity being witnessed. So you don't experience an extremity, but a moderate. So the summers are not very hot, winters are not very cold. Summers are not very hot, and winters are not very cold. Okay. Here, rainfall is influenced by the permanent wind system and also by the shifting of the pressure belt. Sometimes you have certain areas where the winds become onshore, certain areas where the winds become offshore. So that is enough to influence the rainfall. This is further classified into various types: CFA, CFB, CW, and CS. So here you have hot and humid summers and mild winters. It extends between 30 to 50-degree latitude northwards and southwards from the region of equator. These regions are typically the eastern and the western extremities of each continent. So sometimes summer months may feature convective thunderstorms and winter months may feature mid-latitude cyclone. Remember, the western disturbance that we talked about, that is to be observed in this C type of climate. So this is where you have the C type. Generally across the coastal areas is where you will experience the C type of climatic conditions, the coastal areas in general. Okay. So here around the region of Gulf of Mexico, this is also what is referred to as the Gulf type of climate. Then in the region around Britain, in the region around Western Europe, here, which wind pattern will you observe in these areas? Which permanent wind pattern will you be observing? Westerlies. So westerlies here, will they be bringing rainfall or not? Yes. So here you will have daily occurrence of rainfall, and you will have marine climatic conditions, that is moderation in climatic conditions, temperature conditions. This is what is referred to as British type of climate. Here, the rainfall that you receive in this portion, that is in the region of China. This is the rainfall that you receive, particularly during the summer months, and that is where you will receive what kind of climate? Summer rainfall. And why summer rainfall? Because during the summer, we have discussed that the ITCZ shifts almost here. So that ITCZ will bring about rainfall. So generally, you will receive some amount of summer rainfall. This is your China type. Okay. Then you have the aspect of Mediterranean climate. This is where you receive rainfall during the Mediterranean during the winter months due to shifting of pressure belts. That is where it is the Mediterranean type of climate. So you have the various different types of climatic classification. That is CFA, that is rainfall throughout the year. For example, in the region of Gulf of Mexico, in the region of United States, in the coastal area, you have the rainfall throughout the year. CFB, this is what is referred to as the British type. CS, that is the Mediterranean type, and CW, that is the China type. So here you receive winter rains. Here you receive summer rains. Okay. So only this much is there to understand for your prelims. Winter, summer rain, why it happens, that's it. Okay. So here, CFA, that is the humid subtropical climate. So it lies on the eastern part of the continent, and that is in the case of the Gulf type, you would have observed no dry season because the air masses, they are particularly moist and unstable, causing rainfall throughout the year. So eastern US, some parts of China, southern Japan, northeastern Argentina. So that is where you have the Gulf type of climate. Annual range of precipitation is not very high. So it is not equivalent to the A type of climate. The range of rainfall or the amount of rainfall received is particularly less here. But still, the moisture is sufficient because the temperature is lower as compared to the A type. So even this much amount of moisture is sufficient here. So this is where observe that the rainfall is received throughout the year. Okay, this is for Memphis, Tennessee, which is there in United States. Then these are the C type climate again. Then we come to the British type or CFB, British type. So this is slightly to the polewards as compared to the Mediterranean climate. Polewards mean northern region. So this is the region where you experience Mediterranean climate. This is where you will experience the British climate. That is the western part of Europe and also the region of Britain. So here in the northwestern Europe, then west coast of even North America, north of California. So these are the areas where you will receive high amount of rainfall only because of the westerlies and the marine influence. So due to marine influence, the temperature is moderate and in winter it is warmer than its latitude. Okay, so what does this mean? So during winter, as compared to the same latitude, this area will be much colder, right? Whereas this will be warmer because there will be influence of the water body. Annual range of precipitation varies between 50 to 50 centimeter. Winters are milder. There is heavy rainfall whenever you have the development of a temperate cyclone, which happens. Okay, why it is known as British? Because it is observed in the region of Britain. And again, I would request, I understand that yesterday itself we celebrated Independence Day. So patriotism is something which runs very high in our bloods right now. So let's not get patriotic over these things, that why don't we have an India type of climate, why British type of climate. Now that we have become independent, these climates should be referred to as India type of climate. So we will use our patriotism somewhere else. This is basically the Köppen classification, and Vladimir Köppen had got nothing to do with the British role in India, etc. So let's not judge that. Let's not judge our climatic classification based upon that. Okay. So that is to put the questions like, sir, why not any Indian type of climate? Why only British type? So those kind of questions which are coming, hold your horses. Tomorrow, if let's suppose after clearing the civil services, you become a geographer in detail, you develop and research your own climatic type, name that as India type of climate. Okay, whichever portion of country that you are coming from, name that as India type of climate, and accordingly the world will also follow. Okay, now here, that is the west coast climate, marine west coast climate that we have. This is experienced typically across the coastal areas in general. Across the coastal areas, you will experience the marine west coast. Then you have the CS, or the Mediterranean type of climate. Mediterranean type of climate, CS, means summer is dry, winter is when you receive rainfall. And the reason is very simple here, guys. Why is it that you receive rainfall in winter? We have studied about that reason as well. So during the summer, the subtropical high pressure belt will be here. So this is the region which will experience what? Sinking air, dry conditions. But during the winter, the subtropical high pressure belt shifts somewhere in this area. So that is where in this region you will have the westerlies which will start to move. Plus development of frontal cyclone also happens. So that is why this region during the winter, particularly due to the shifting of the pressure belts, will receive rainfall. So such type of climatic conditions exist near the Mediterranean Sea along the west coast of continents in the subtropical region. Comes under the influence of subtropical high in summer. This creates dry conditions. Okay, creates dry condition. And then westerly wind in winter, which becomes onshore, and also you have development of cyclonic circulation. So precipitation is heaviest during the winters due to mid latitude cyclone. There is hardly any rainfall during the summer. So this is where you will find the growth of fruits, right? Fruit cultivation is done in large numbers. You will find very large orchards in general. So fruit cultivation is very common. Okay, various different types of citrus fruits, olives, etc. you will find to be present there. Then you have CW, or the China type. Here the rainfall is received due to the portion of the region receiving rainfall due to the shifting of the ITCZ. So when the ITCZ shifts during the summer season, that will attract the winds, and that low pressure will create rainfall. That is your China type. Okay. Then we move on to the D type. So these are also present in the higher latitudes, but in the continental areas, that is in the inland portion. Now we have studied earlier that inland portion, they experience very high temperature, they experience very low temperature, particularly during the winter. The range is very high. So accordingly here, these are the continental areas where you will experience D type. In the southern hemisphere, you don't experience D type because you don't have much of a land mass which can represent the interior or the continentality at these latitudes. So that kind of a landmass is prevalent in the northern hemisphere itself. So cold snow forests, forest climate as it is referred to, it occurs in the large continental area in the aspect of in the northern hemisphere between 40 degree to 70-degree north latitudes in the region of Europe, Asia, and North America. Summers are typically warm but can also be cool, while winters are significantly colder. So northern portion of Canada, also the portion when we talk about the region of, let's suppose, Siberia, these areas. During the summer months, the average temperatures can climb to around 10 degree, while in winter months it can be less than minus 3 degrees Celsius as well. Here also you have a classification not required for the examination. UPSC has not asked about the codes till now. So please don't start delving upon the codes in detail. Just understand DF means coastal areas which will receive rainfall through and through. Then DW, cold climate with dry winter, precipitation during the summer. DS, cold climate with dry summer. Okay. So here DF, cold climate with humid winters, occurs poleward of the British type of climate, and mid-latitude steppe. So here you have rainfall throughout the year. Frost-free season is short. Mostly you will have snowfall. So not only rainfall, you have snowfall as well because of low temperatures. Annual range of temperatures are large because the winters are very, very cold. So this is, for example, observed in the region of Canada, where you will observe that the rainfall is occurring throughout the year. Okay. So observe here, rainfall is something which is consistent, or precipitation is consistent throughout the year. The winter temperature can be as low as minus 20. Summer temperature can be as high as around 20 degrees Celsius themselves. So that is your DF type. Then you have DW, observed in the region around Siberia. So you have the winter anticyclone high pressure Siberian high. We have discussed about the Siberian high as well. Siberian high. Guys, I understand that this is a portion which is very theoretical. While you reading, you would want to bang your head against the wall as well. That what is it? I wanted to become an IS officer. Why am I confronted with this? So please restrict this particular portion to the end of your revision aspect. Okay, don't spend much energy while covering this. Otherwise, these are such topics. Every subject you have such topics where you will lose complete interest. For example, when you read, I'm sure when you would be reading the portion of reform movements in the modern history, you pick up to study about Bhagat Singh, you pick up for studying about, let's say, Chandrasekhar Azad and Mahatma Gandhi, and you are left with social reformers. So there also many people lose interest. This is such a kind of a portion. So please concentrate only on those areas that we have talked about: Mediterranean, equatorial, savanna, British, China type of climate. Okay. So that is where you can restrict your portion. It will be very beneficial. Okay. So the development of pronounced winter anticyclone and its weakening in summer provides the almost like a reversal of wind, which brings some amount of rainfall, or rather snowfall in general. Then we have the E type. E type is a polar climate. Polar climate to be found in the region around Arctic, in the region around Greenland, and in Antarctica. That is where you experience the polar type of climate. So here also you have a classification into EF and ET, right? So polar climates exist poleward beyond 70-degree latitude. Temperatures are usually low all the year round in the polar climatic condition. Warmest months also will see a temperature at max around 10 degree. Then usually occurring in the north coastal region of North America, that is North Canada, northern portion of Eurasia, Greenland, and Antarctica. So you have the classification into ET and EF. ET is where you have tundra, that is mosses and lichens will be growing there in the in the warm months. These are all the areas of permafrost where the subsoil is permanently frozen. So ET is so called after the types of vegetation, for example, mosses and lichens. This is the region of permafrost where the subsoil is permanently frozen. Now, in the region of permafrost, let us try to interlink the concepts. In the region of permafrost, which kind of mass movement is observed, guys? Are we able to recall? Or is it like we had studied it in the past life? Very good, Abhijit. Basu, correct. Ajit, Ajit, my dear friend, the question is which kind of mass movement is observed, not which kind of animal is observed. Okay, so, okay, it is solifluction. Solifluction is observed in those areas. And yes, you will find glacial deposits and glacial landforms as well. Okay. So during summer, the tundra regions have very long duration of daylight because of the bending of the planet on its axis. So this is your E type. So the coastal areas in general, they will be ET, these will be ET, right? The interior area of Greenland, these will be EF. That is completely frozen. That will be your EF. So this is your ET, where even during the warm months, you will observe that the temperature goes to the region of 4 to 5 degrees Celsius. And during the cold months, always it can come to around minus 30 as well. Then EF, these are the ice capped regions of the planet. Surface is permanently covered. Even during summer, the temperature is below freezing point. So, interior of Greenland and Antarctica, where you will observe perpetually the temperature is below freezing point itself. Okay, that brings us to the end of the Köppen classification. Again, I will reiterate the pattern of the question, pattern of the classification. Closest to the equator, you have the A type. Then, as you move slightly farther away, B type. Then, as you move slightly farther away, C type. In the interior of these continents, D type. Only in the northern hemisphere, closer to the poles, you have the E type. Let's take a look at questions which have been asked from this area. The seasonal reversal of winds is a typical characteristic of which of these climatic type? Seasonal reversal of winds. Usna, wrong. Correct. Gulam, correct. Gaurav, correct. Krishna, wrong. Maria, incorrect. So it is the seasonal reversal of wind is a characteristic of the monsoon climate where you have a reversal, a complete reversal of the wind which is done. That is your monsoonal climatic type. Consider the following statements. This is your one, this is your two. Let's name this A, B, C, and D. Read this question carefully. Okay, read this question carefully and attempt this question. I will give you 30 seconds for this. Consider the following statements. Okay. Apply the same logic that you have applied in the case of the El Nino questions, the El Nino and IOD questions. No, Somile, that is incorrect. Gaurav, absolutely correct. Good. Somile, that is why read the question statement correct. Garvit, correct. Vivek, incorrect. Gulam, correct. Shalja, wrong. Lakshmi, Akshita, Ayush, correct. So good. Majority of you have given the correct answer. So here, the winds which blow between 30-degree north and 60-degree south latitude throughout the year are known as westerlies. No. What is incorrect here? Here it should be 30-degree south and 60-degree south. Between 30-degree north and 60-degree south, you don't have any wind pattern which blows. Right? So here by changing north, UPSC has played the trick. Okay. So that is where this is incorrect. Then moist air masses that cause winter rains in the northwestern part are a part of westerlies. This is going to be correct. So the correct answer is B, 2 only. Which of the following following is the characteristic climate of the tropical savanna region. Rainfall throughout the year, rainfall in winter only, extremely short dry season, a definite dry and wet season. Yes. Good. Most of you are correct here. So if you are able to get these questions correct, these are the questions that UPSC will ask from the climatic classification. Okay, so then you don't have to worry whether this is boring, whether this is tedious, etc. You don't have to worry about that. Very good. You have a definite dry and wet season, which is observed in this case. Okay, beautiful. Consider the following statements. Duration of monsoon decreases duration from southern India to northern India. The amount of annual rainfall in the northern plains of India decreases from east to west. Which of them are correct? Yes. Shargun Sayyid Tarun correct. Garvit incorrect. Somil correct. Yes. Tarun, you were correct earlier. Now you are incorrect. Yes, Shailja. Good. So duration of monsoon decreases from south to north because the monsoon reaches the north last, retreats from it earliest. So that is correct. Amount of annual rainfall decreases from east to west. We have discussed that as you move away from the source of moisture, the rainfall reduces. Okay. During a thunderstorm, the thunder in the skies is produced. Oh, two Taruns are there in the class. My bad. So during a thunderstorm, the thunder in the sky is produced by meeting of cumulonimbus clouds in the sky, lightning that separates the nimbus cloud. So this is about thunderstorm. Violent upward movement of air and water particles. So what creates thunder into the sky? Yes, all of you are correct in this. Climatology, Somil, is a portion where you will find a lot of questions coming from. So, regardless of the changing pattern, whatever you might hold, climatology is an area that UPSC will continue to ask questions from. Yes. Okay. So, here, thunderstorms are created. Why? Thunder is produced. Why? Because when lightning happens, the air immediately in the vicinity of that lightning significantly heats up and violent expansion of the air happens. That is why thunderstorms they do take place. This is a question that we have already discussed. Okay. Now, final question. Each day, there is one more question, I guess. Each day is more or less the same. The morning is clear and bright with a sea breeze. As the sun climbs high in the sky, heat mounts up, dark clouds form, then rain comes with thunder and lightning. But rain is soon over. Which of the following regions is described in the above passage? Good. Good. It is the equatorial area where you receive rainfall on a daily basis. Okay. So each day you receive rainfall. That is the cumulonimbus or the convectional rainfall. Why are dewdrops not formed on a cloudy night? So, clouds absorb the radiation released from the Earth's surface. Clouds reflect back the Earth's radiation. The Earth's surface would have lower temperature on cloudy nights. Clouds deflect the blowing wind to the ground level. Why is it that the dewdrops are not formed on cloudy nights? Correct. Yes. So here basically what happens, you have the cloud reflects the heat, so the earth warms up again and hence dew is not formed. So clouds reflect the heat back or reflect the earth's radiation back again. Okay, so that is where we'll finish the portion for today, and we will finish the portion and we will get back to the portion of oceanography from tomorrow. Okay, so we will continue from the portion of oceanography tomorrow. So this is just for your reference. Okay, so tomorrow we meet again, and then we will take some questions furthermore. So no, Yashi, that is more than sufficient. Yes, Madhuri, I'll take a look at it. So till that point of time, do take care of yourself. Goodbye. Thank you and good night.